Check, check. dead ESP32s. One of them we don't know how to do.
Yeah.
Hello everyone and welcome to day 3 of the Australian Rover Challenge 2024. My name is Henry and I am joining you today from Roseworthy where we'll have the iSpace Space Resources task in this year's challenge. First up we have Project Scorpio from hailing all the way from Poland. They'll be starting their task time at 9 a.m. local time, which is coming up in just under 10 minutes. So they're currently furiously setting up their base station behind me over there, and they'll get their rover out onto the field in about 5 minutes time and then start the task shortly after that. So the iSpace Space Resources task today is essentially made up of 3 separate parts. The first one is that they'll have to prospect some icy regolith samples and then see if they can actually extract water from those samples. I'm really excited because we've had this task in the challenge for, I think this is the 3rd year, and we haven't actually had any team successfully process the samples for water thus far. So I'm really excited to see, hopefully some teams today come out with some liquid water from those samples. The second part of the task is the teams will have to analyze another sample which contains ilmenite, which is a magnetic material that is also found on the moon. So they'll have to use their rover, navigate to the sites that we've marked out for them, and see how much ilmenite is present in those samples. The third part of the task is they will have to go through not really an arduous, but a little bit of a presentation to our specialist judges today, who will essentially mark them on their approach to the task and whether they were able to accurately determine what the concentration of water and ilmenite were in those samples. So, just to repeat that again, we've got Project Scorpio from Poland coming up first in the iSpace Space Resources task. And stay with us. They'll be starting the task in just under 8 minutes' time. So we've got live shots of Project Scorpio's rover here. It's just on the weigh-in scales over there. So for each of the tasks, we do have a weight limit for the challenge. For this task, I believe it's 50 kilograms, and they have opted to have their science payload attached to the front of the rover there. So it's likely that will be trying to image, process, and excavate some material from our sample sites, and then try and process them to get some liquid water for us. Like all of the other challenge tasks, this task is worth up to 100 points. So the teams will be trying to maximize as many as they can across those 3 separate areas: the water processing and prospecting and processing, the ilmenite prospecting, as well as the presentation afterwards. So the team is getting ready to bring the rover out to the challenge arena now, where they'll place it in the starting area for this task.
We're just not built like you, okay?
Yeah, let's get better.
Testing. Oh, I think it's back. So you can see the team has just moved their rover out onto the lander for the start of this task. There was also a shot previously of the team setting up in their base stations. They've got the team in front of their computers there, so that's all of their own hardware. And so this team, once the task starts, those doors will close and they will only be able to operate the rover using what the camera feeds and the other sensor data that will be coming through on their screens there. So not at all a trivial task. When you've got the wide angle and can see everything that's going on the challenge arena, it can be sometimes seem quite obvious of where to go. You know, navigate around the left of the solar array and then head out to the crater that we've got on the back left of the task arena. However, when you're only viewing it through maybe a little bit of a choppy, maybe a low resolution camera feed, it can be quite difficult to know where you are and where you need to go. Of course, those conditions are exactly the same as what we'd expect to see on the moon or on the lunar surface, which is what this challenge is exactly designed to do.
You guys are starting with the truck.
So you can see the team has positioned their rover in the starting position for this task. So that's not actually on top of the lander. It's just about in the smack bang in the middle of the challenge arena. So we essentially have had the teams to descend from the lander ramp in the Australian Space Agency post-landing task. And so this is simulating that the lander is already on the surface and now it's explored the terrain around it. And now it's going to have a look at what icy regolith deposits might be present. So we have Project Scorpio from Poland up first. Their task time starts in just about 20 seconds, and they're currently sitting in first place. So they'll be setting the bar today early, first thing in the morning, and we'll see exactly what they can do, and they'll be the score to beat potentially. We'll see how they can do in this task.
We can talk after.
Oh, so it's going to start in 39 minutes.
Good morning.
So I've just been notified by the judging team that we are experiencing a little bit of a delay getting all the samples out. So Project Scorpio will be starting at 2 minutes past 9 local time. So we have a magnificent team of volunteer judges on hand, and they're desperately trying to get the prepared samples out onto the field so that Project Scorpio's Rover can go and then investigate them and prospect and process them, hopefully for liquid water, to earn themselves some points in this task. So stay with us. The Project Scorpio from Poland will be starting their task in just a few seconds. So one really cool thing about the Challenge Arena early in the morning, the Rover has actually started moving. So Project Scorpio's task time has started, and they are making their way over to the crater in the back left of our Challenge Arena, which is where our icy water samples are. What I was going to say just a second ago is that a cool thing about the Challenge Arena early in the morning is that with the sun at a reasonably low angle, you do get some quite long shadows cast over the Challenge Arena, which is similar to what you might expect at the high latitudes at the north or south pole of the moon, where we might expect to find these icy regolith deposits. On screen now, you can see the Project Scorpio base station GUI, or graphical user interface, which is what the operators in the base station are seeing and using to operate their rover. So, in no time at all, Project Scorpio's rover has made it over to the icy samples. So you can see on their base station computer there, you can see the image that they're looking at, and you can see there's 2 tubs of that icy regolith just in the middle of the shot that they will be trying to investigate.
I had a call come through that delayed me by 10 minutes. It's really hard to speed around here and get caught up on Google Maps.
Yeah.
feel like I've been in call for the last 3 hours.
Really? Yeah, right.
So it looks like the rover is just maneuvering itself to get in the right spot to potentially take a sample of one of those icy regolith containers. They've got quite the instrument pack on the front of their rover there, which they'll use to maybe ingest some of the sample and then analyze it for its water content. And if they deem that it has lots of water in it, they will then try and take some additional on board and process it to get liquid water.
So if you can actually bring it on a Rover and process it and deliver liquid water, that's more than
We did it yesterday.
But Uniadelaide's got a whole rotating, like the whole fire, and a heat element they will go.
Yeah, for sure. For
So the
sure.
practice condition there.
They have something on the sample.
Supposedly that's the energy that they are creating.
And they do regions of interest.
Yeah, and we want to
So it's good to have some of the other teams supporting Project Scorpio in the stands there. So we've got members from Monash Nova Rover checking them out. Hopefully supporting, hopefully not trying to figure out some strategies for when they're up just before lunchtime today, I believe. So you can see the base station team from Project Scorpio are having a look at what they can see on their screens and trying to analyze exactly what their next move should be. So I can see there, so this must be some sort of instrument or potentially a microscope, having a look at the surface of the sample, potentially for signs of water within it. So it looks like the rover did just make a little bit of a move. I saw the instrument did essentially probe that first sample, and it might be going in for the second at the moment. So we have two icy regolith samples in the crater back there, and they have different levels of water within them. One has a higher amount of water content and another lower. So there are points up for grabs to essentially tell the judges what percentage of water the team believes is contained within those samples. There are additional points available for then processing some of that water and delivering it to the judges as liquid water, which is something that has been in the competition for a couple of years now, and no team has been able to successfully do just yet. So I'm really excited today. So hopefully we'll be able to get some liquid water from at least a couple of teams. And there is quite a lot of points up for grabs if they are able to do so. So from the base station screen there, it does look like that might be some sort of some sort of close-up camera that the team is able to get really close to the surface of the sample and look for visible signs of water in there. So they could do so by potentially looking at the colour of the regolith and how that compares to the other sample or the samples around it which don't contain any water. Or there might be other signs, such as just visibly being able to see the presence of ice or liquid water.
But then, yeah, take the 60% penalty. You fill your entire thing up. I was thinking it's tragic. Get a shit ton of water from every.
So this is the task which focuses the most on scientific analysis, which is obviously is a very, very important part of space exploration and space technologies. So in the previous days, we've had the teams essentially navigate around the surface like they've just landed on a lander to the lunar surface. And then just yesterday, we had teams, excavating material and then constructing features on the lunar surface, which will be very useful for additional lunar surface infrastructure. And now today, we have them analysing samples for water content, as well as analysing some samples for ilmenite content. So ilmenite is a mineral which contains some magnetic and other metallic elements, and so it's thought to be quite useful on the lunar surface for building structures and other infrastructure.
Got a reason? Probably.
So you can see it looks like one of their main instruments, that black cylindrical piece in the middle there, which could house an auger or something similar, was descending towards the sample just between the wheels of the Project Scorpio rover there. It's just stopped. Maybe they're assessing whether to proceed with that sample or not, but we might see in a couple of seconds that they will continue lowering that instrument. So again, this is a fantastic view that you can see from the other camera angles we have. You can quite clearly see that the instrument they have is lined up with the sample, or it looks about so from where I'm sitting. But these are the images that the teams have to look at to assess whether they're lined up or not. And so you can see being able to integrate those different technologies, those different camera angles into their rover to ensure that they can exactly see what they need to make sure they're lined up on that sample can be quite difficult.
Yeah, I know, but it was also because of it being a crater. So that's simulating being in a crater. So underneath this walking signal. Maybe that's. I'm not sure. My thing was for div is, do we want to take the chem blank now, or do we want to take the chem blank? Okay, from yesterday, like midday, whenever we get to the left, so okay, cool. Then we close.
So from my position, I can hear what appears to be a bit of a whirring sound from the rover. So my assumption here is that that black shroud has actually covered the sample, and there is probably an auger drill which is drilling into the surface of that sample to collect some of that sample. So the teams have a really important decision to make, because like I said before, there are two samples there containing different quantities of water within them. There are points available for the mass of water that they're able to process out of that sample. However, so you may think that it's obvious to just go with the sample that contains the most water. However, in reality, that sample, when frozen at lunar surface temperatures, which around the South Pole can reach as low as below minus 100 degrees Celsius, can be extremely, extremely hard. We're trying to replicate that today by freezing our samples in an on-site freezer, and they only get put out onto the challenge arena once the team is ready to go. So it looks like the black shroud is descending towards the sample again. They might be taking another bite to try and excavate more of that icy regolith, bring more on board before they start processing. I can hear that drill has started up once again. So a reminder, this is the iSpace Space Resources task. The task time is 40 minutes. And so the team has still over 25 minutes left to go. So they've got plenty of time. And their aim here is to try and process these icy samples that we have prepared on the challenge arena and get liquid water from them. There are also additional points for going to our sites which contain ilmenite and trying to determine what the proportion of ilmenite is in those samples. They'll also have some points available at the very end for justifying their approach to our judges in a presentation. So in that shot, you could see just the tip of the drill poking out from that shroud. So my assumption here is that shroud is being used to keep the sample within it and not get spun or lost during that drilling process. They're then, I assume, going to try and transfer the sample that they've collected into the grey cylinder on the right-hand side. And most teams today will be using an evaporative and then condensing method, I assume, to get their liquid water. So they'll be heating those samples up, trying to evaporate the water within them, and then trying to condense that water back into a liquid. So Project Scorpio is spending quite a lot of time over in our crater trying to excavate our icy regolith samples and then process them for water, which is completely justified. They've got plenty of time left on the clock, and there are quite a significant number of points available for getting that water from those samples. So having a look at their base station computer there is a really interesting insight into all of the different sensors and feeds which they've got going on. You can see there's, ROS node status, CAN bus scanner, and other things like that, RFID data, encoders config. So they've got all of these different sensors and data streams all coming into the single place, which they can all be quickly interpreted by their base station operators.
Did any of you guys bring like binoculars? That's what I want to bring.
So you can see in the image on the left there, that auger and that drill is descending below the surface. You can see they've got it on some linear guide rods there, which I think is definitely necessary, and because the stiffness required to get through that incredibly hard icy sample would require something that stiff. So you can see the regolith, the auger is ascending back up, and I'm assuming that they're transferring it over into the grey cylinder on the right-hand side, where their processing to get liquid water out of that sample will take place.
Well, no, I think it's like as they raise it up, it's just cold, and then as we're spinning it, there's nowhere else to go down. Yeah, because they keep drilling as they pull it up. They're still drilling the thing, and the second it reaches the point, they drill, and the only way it can go is out, so it's just
So that auger is going back down, descending towards the sample yet again. So I'm not sure whether this is part of the plan or they're just trying to get as much of that sample as they possibly can. So the general gist is they're lowering that auger, drilling into our icy sample, raising it back up, and then they're backing out that drill with some sort of tool on the top of their instrument there to then transfer the excavated sample into that grey cylinder on the right-hand side. I'm hoping at one point the lid on that cylinder might close, and then they'll start heating up that regolith to try and evaporate the water content that is within that sample.
No, we did hear about that. It's harder on the surface.
So they've taken yet another swipe at that sample, and then they're raising that instrument back up, and then they'll yet again transfer whatever they've been able to capture into that into the pot on the right-hand side. So I believe there are up to 50 points available in this task just for this process alone. So the team will get 30 points if they can get any liquid water out of this sample at all. So you can see there. So there's 20 points available for prospecting. So there's 4 sites on the challenge arena this morning. We've got 2 icy water enriched regolith sites, which is where the Project Scorpio rover is right now. And we've also got 2 sites enriched with ilmenite, which is a mineral, a magnetic mineral that you can find on the moon. So the team will get 5 points for each of those sites that they visit. So they've already achieved 10 points for visiting those 2 water sites. And there's an additional 50 points up for grabs for trying to extract water from those sites. So there's 30 points for extracting any liquid water whatsoever. And so I'm really excited today to see which teams might be able to extract some liquid water. We've had this task in the challenge for 3 years now, and no team has been able to do it just yet, which shows just how difficult that really is to do. And then the remaining 20 points out of the 50 points that I mentioned previously is for the mass of water that they're able to extract. So if there's multiple teams that get water out of this icy sample, the team with the highest mass extracted will get all of those 20 points.
Yeah, quiet. Did they just close the show? Yeah, they closed the show now. It was open. So they just started feeding. Yeah, just started feeding. No point. So it likely has to heat up though as well. So like, it's more than that. Yeah, there was a bunch of tech issues. No, as in like not their fault. Like they didn't have to sample that before that. Yeah. Which is kind of dumb because they started the timer the second they started moving. Yeah.
So what are we waiting for?
Yeah.
I'll just show that they can go.
We should start cooking it nice. We're start cooking it and just chilling, just start spinning in the spot. I don't want to burst that big film like. Yeah. Comptate tells things you didn't think were possible to a person.
I don't think we'll have to fix it. If we did.
If we have extra time, I feel like we'll If you get more water, we get more points.
Think about it. You can do stuff.
Yeah, kind of. Well, yeah, but
But
every
normally the
single
kiln
time.
is hot enough that like when you add in just a small amount of water,
Yeah,
the trouble is that when you heat it already and the stuff is in the sheet, it's dry slime. It's pretty like it's pretty solid.
Well, that's the longer you heat it though for. Like, Papa Wheelie? I don't think it's mentioned in the rules of the camp. I'm pretty sure. Yeah, if one's doing one.
One's 15 and one's 20. Because I should check carefully the rules because it says.
It's like go to.
So as I expected, we on the right-hand side of the science unit or the space resources unit that the team Project Scorpio has on the front of the rover, they have closed the lid on that little container on the right-hand side. So I assume that might be heating up right now and trying to extract water from the sample that they previously collected. They've got another instrument on the left-hand side of the front of the rover, which is currently descending into one of the ilmenite samples that we've prepared on the surface. So you can see it's just gone into that sample and now it's raising back up a little bit. So I'm assuming there is some sort of camera or instrument on there which might be able to determine the concentration of ilmenite in that sample. So the team will get 5 points for traveling to each of these sites. So there's one ilmenite sample directly between those two front wheels. There's another one just out of the shot, just to the right, which I'm sure they will travel to after they're done with this one. The team will then be able to get additional points if they're able to tell the judges in our presentation, which will happen after task time, how much ilmenite was present in these samples that they are currently probing. So it's fantastic to have Project Scorpio from Poland at their second ever Australian Rover Challenge. They joined us last year for the first time and managed to finish in second place, which is an amazing achievement considering that they did come from literally the other side of the world to be here. This year, they might be trying to do one better and come in first place, which is where they're currently sitting in the leaderboard before the points for this task have been tallied. It's great to see the teams innovating each year and adding new designs and technologies to their rovers. So one key new technology for their rover this year, I've been told, is the wheels. So they're a new design, upgraded from last year. They're now 3D printed, I believe in one piece, and I was told that they take approximately 5 days to print each of those wheels because of the internal structure that exists within them. Of course, you can't quite see it just with this shot because of the angle of the sun, but the outside of those wheels are perforated or they are hollow. So they might look like tires and wheels, but there isn't actually any air in those wheels. And of course, that's mimicking what would be real space technology on the moon, because we wouldn't be able to have air tires on the moon because of the lack of atmospheric pressure.
Yeah, I know, but it's really like 5 days.
So you can see, I think it is some sort of probe, some sort of camera or microscope that the team has on the tip of that instrument that's been, going up and down on the surface. You can also see that it can translate left and right. So they are probing different areas and seeing what they can see to try and determine what content of ilmenite might be present. So you can see in this image, there are larger grains of a basaltic material, which is making up the bulk of that sample. And then the darker areas which are filling in the gaps are likely to be that ilmenite. And like I've said previously, the team will score additional competition points if they're able to tell our judges to a high degree of confidence what proportion of ilmenite is present in that sample. So you might have just seen that instrument retracted back up and then it translated a little bit to the right as we're looking at it on the screen. And then it's gone back down to take another image of that sample. So they're doing this all in the name of trying to determine what the concentration of ilmenite is in that sample, which they're doing from that microscopic image of the surface of the sample. So you can see as they lower that instrument to the surface, it comes within the view on the base station monitors for the operators who are controlling this rover without looking at it from our base station tents just behind the arena.
Like, I don't know if they'll. Is this the issue with something like? I'm curious what's happening going on. Like, I want to know how close they work. Like, systems are very similar.
So it looks like Project Scorpio's rover is done with that first ilmenite sample, and it's now going to maneuver around to the second sample to see what they can find there. You can see, even though those wheels have been purpose designed for this competition surface, the fine grain of the sand that we have here, which is trying to mimic the lunar regolith that you would find on the moon, is very difficult to move and turn in. It is very fine, it's very slippery, and it's also it adheres to itself quite a lot. So we've got a great tight-on shot there to that instrument that the team is using, which has 2 degrees of freedom. It looks like it can translate both left and right, and then also move up and down to take an image of the sample which is in there.
Like it actually goes down in the mic block, and then they push it down so that the mic goes this way. Like they use the microphone to focus it, and then.
I think it's the dark noise, the black part.
Yeah, it is. It really is.
So one thing I've just spotted on this instrument, it looks like they have some sort of servo, or maybe that is the camera itself, that blue object up the top of the black, what looks like to be a 3D printed shroud. And I'm interested to know whether they do have an autofocus or something else on there to capture such crisp images of the surface, where you can detail out the exact grains of sand in there and any ilmenite that might be present between those grains. So the team has just over 3 minutes left in this task. They have been able to make it over to all 4 of the sample sites that we have prepared for them. So I know that they've got at least 20 points thus far. They will be able to receive a lot more points if they were able to process any liquid water from that sample. And of course, the whole purpose of this task and to produce liquid water on the moon is for a multitude of purposes, no less to electrolyze it to get liquid oxygen and hydrogen, which can be used as a rocket propellant. And of course, oxygen can be used to sustain life as well. So after the conclusion of this task, the team will conduct a presentation with our judges in their base station, where they'll walk through their approach to this task and also the concentrations, or what they believe the concentrations of the ilmenite in these samples that they're imaging right now is for additional challenge points. So unfortunately, we won't have the scores immediately available for you, but we'll get them to you as soon as we can after that presentation has wrapped up. So you can see that probe once again going into that sample, collecting, taking a high definition close-up image of the surface of that sample at several different points to try and determine that ilmenite content.
It was actually pretty cool. They had a drill that went down, and then when they reversed, they reversed the drill. Sends it out the top.
Yeah, so like it actuates down, drills, then it goes all the way up, where there's like an opening at the top, and then it reverses a little bit, and then the sand shoots out.
They have like an incredible amount of actuators.
Yeah, the kiln actuates as well, and it's so cool.
Because the microscope actuates left and right as well as up and down. They activate.
Actually, it activates.
So the time is rapidly expiring for Project Scorpio here. They've done a fantastic job making it around to all 4 of the competition and surface sites. It looks like they might just be finished up there. I see some hands behind the head, relaxing and preparing for that presentation. Some handshakes, some celebrations. Fantastic work to the team there. Let's give them a round of applause. So like I said, they will be conducting their presentation with our judges in around 10 minutes time. So they'll be frantically preparing for that and preparing to tell our judges what they were able to find in those samples.
All of us at once. I'll say 3, 2, 1, and we all go.
So it's no easy feat being able to travel around to all 4 of those sample sites. It's something that we take for granted a little bit. Having a reliable and repeatable rover is not easy in the slightest. There are a myriad of issues that can go wrong at any time, no less from communication, mechanical, electrical, software. These pieces of equipment are just so complex, and getting everything right all at once, exactly when you need it to, can be very difficult.
Since opening our campus 150 years ago, we have constantly evolved. From our first pioneers in gender equality, we have inspired a new generation of leaders. If we saw closed doors, we'd be first to burst through them. As we have evolved the world around us, helping our students reach new heights. We have given shape to the laws of nature and the nature of our laws. We have helped preserve ancient languages while breaking new ground with the written word. Although we are proud of what we have achieved, we remain resolutely focused on the future. By continually becoming the change we wanted to see, the University of Adelaide has evolved into one of the world's leading universities. Because by making history today, we will build the world we want for tomorrow.
The universe's newest city is home to 1,000 people. And every year, over 10,000 come to visit. Only 20 years ago, this city didn't exist. It's the result of pioneers sending rovers, then discovering water. The hydrogen and oxygen separated from water becomes energy, creating the foundation for a fuel station. And with the fuel station came scheduled flights, followed by settlers. Soon, settlers required more diverse skills, attracting new specialists for construction, steel, communications, energy, transit, agriculture, medicine, and more. People travel from far and wide to see this new city. We call it Moon Valley. The moon is the new staging ground for your next level business. Expand our planet. Expand our future. iSpace.
So you can see our next team up for the iSpace Space Resources task is Team Atlas from Bangladesh. So you can see them setting up in their base station. Their task time will start shortly, and our field crew are quickly readying the field to make sure that they can get underway. So the team has placed their rover on the starting point for this task, which is smack bang in the middle of our challenge arena, because the team has spent the previous 2 days, essentially, they've landed and descended from the lander and investigated the local area. So it looks like the team is underway. The rover is moving. So this is Team Atlas from Bangladesh competing in the iSpace Space Resources tasks. They are making their way over to the 2 ilmenite samples that we have prepared on the field. So this rover is quite fast. It has made its way there in no time at all. And it looks like they have some sort of probe on top of an extended arm in front of the rover. And I assume that they'll be using a linear actuator to try and, you can see it just moving down there, to try and probe the sample and see if they can determine what the ilmenite content in that sample may be. So the rover is quite speedy. They're trying to line up for that second ilmenite sample. And so they'll get points for imaging that sample, being able to show the base station judges that they are able to see that sample on their screens that they're using in their base station and using to operate this rover right now. So the rover is now making its way into the crater that we have at the back left of the arena. You can see the base station operators there looking at the monitors and their screens and trying to use the information presented to them to navigate around the surface. So there are two icy regolith samples that we've got prepared in the crater at the back of the arena, which you can see on your screen there. So the team will be able to receive some points for both imaging those sites, just being able to show the base station judges that they have, they can see the sample sites on their screens, and then they'll receive further points if they're able to tell the base station judges in the presentation that will happen after the task what concentration of water is present in those samples. So Team Atlas are currently on the field competing from Bangladesh, and they've come up against a decent amount of adversity in this competition thus far and showed an extreme amount of resilience to still be in the competition competing in this task today. It's fantastic to have them here at the challenge and have them competing in the iSpace Space Resources task today. For the first task on Thursday, their rover was a little bit overweight, and so they had to make some quick last-minute changes to reduce the weight of the rover, which you can see with their makeshift chassis, and by also removing some of the two wheels actually from the original rover to bring it within the weight constraints for the challenge.
When you have a liquid nitrogen over here, we could freeze it. I think it's because they have a higher, like if you're in a, this sounds poor, if you're in a tertiary area, income is a lower, corresponds to the higher philosophy income. So they've got more, you know, they've got like more demand, more experience, something like that.
I don't live anywhere near KFC. I live in like mountains. I live like near the Daddy Road.
What was your Emerald? That's so cool. Yeah. Drive truck. But it's not too bad to want it. Yeah.
If I go in the morning, it's about 5. I get like the tail and the 2 pounds to get it at 9 a.m.
Yeah.
But it's drive to one day. I'm like,
It's not that far from there.
Yeah, I know people are like twice as close and they're like, yeah, it's like 45 minutes.
20 minutes to go to that. 25 minutes.
So you can see Team Atlas's rover has, I think it has deployed that sensor which is on that boom or that arm on front of the rover, and they've got they managed to attach a camera to that boom, which is facing down that white spherical thing that you can see, which I imagine is what they're using to make sure that that camera is lined up with the sample. So you can see with the picture in the bottom right there is the Team Atlas team in their base station. So they're controlling this rover from their base station where they have no line of sight to the rover out on the field. And so it means that all of the decisions that they're making, all of the control inputs that they are doing has to come from the sensor output and the camera images that are being fed to them wirelessly from the rover into that base station, which can be incredibly difficult to do. Obviously, we're doing this to mimic exactly the conditions that you'd face when controlling a rover on any other planetary body, or particularly the lunar surface. This rover is quite speedy. Blink and you'll miss it. And it is backed up, and it might be lining up for one of the other samples. So, a reminder, if you've just joined us, this is day 3 of the Australian Rover Challenge. You're joining us for the iSpace Space Resources task. On the field right now is Team Atlas from Bangladesh, and they're competing in this task, which requires them to do 3 things. The first one is to prospect and potentially process 2 sites of icy regolith. Regolith being the soil that's loose topsoil on the lunar surface, and try and process those samples that we've prepared and try and produce some liquid water. They'll also get points for telling us what the concentration of water in those samples is. The second portion of the task is going and imaging some ilmenite samples. So ilmenite is a mineral which is found on the surface of the moon, which is metallic and magnetic and is useful for a range of purposes such as 3D printing on the moon or building other infrastructure. And the third component is the presentation, which the base station team will be conducting at the conclusion of the task after they've prepared their findings, prepared their results, and then will be quizzed by the judges in their base station to present their scientific findings. So this task has been designed exactly to mimic the activities that hopefully space agencies and other entities might be conducting on the moon, potentially this decade. Water is an extremely valuable resource because it can be electrolyzed to produce hydrogen and oxygen, which can be used to produce fuel on the surface of the moon, or what we say is in situ. In situ being the IS in ISIU, which stands for in situ resource utilization, which is the blanket term used for essentially getting resources or where they exist. So the benefit and that you can get from producing water on the surface of the moon means that you essentially don't have to take it with you. The Apollo program, back in the moon landings, they had to take all of their fuel with them to the lunar surface to get back to the Earth. Now, the moon doesn't have as strong a gravity well as the Earth, so it requires a lot lower mass of fuel to do so. However, if we're able to, all of the mass that you have to take from Earth means less mass that you can take to the moon, which is going to be critical to meet the scientific and engineering goals in the next coming years. You can see the Team Atlas rover is maneuvering once again, and they've got that probe on top of that arm at the front of the rover, which they might be trying to line up with one of the water samples to try and determine what content of water might be present in that sample. Meanwhile, we've already seen Project Scorpio from Poland compete in this task earlier this morning, and they'll be conducting their presentation with our judges in the base station as we speak. So it looks like the base station team is trying to debug and trying to figure out exactly what move to do next based on the information coming to them directly from the camera feed live on the rover that they're receiving wirelessly to their base station. You can see some of the challenges in operating this rover. They were only able to have those cameras on the rover itself, so they wouldn't be able to see past those crater walls that we've created on this challenge arena.
It's from around the world. So Team Atlas has 40 minutes to complete this task. They're almost halfway through. They've been able to make it over to both of the ilmenite samples that we've prepared for them on the challenge arena, and they've then made their way into the mock crater that we have, and been able to make their way to the icy regolith samples that we've also prepared for them on the surface.
In terms of how much do you have, I'm not sure. It's like a lot. Yeah, good. I think it's gathered around cold.
I'm not sure about
And it's mostly like just like rocks and like ice, very cold. Because there's no like structure to it. There's nothing normal like mushroom. And like they're just like a nice rock little water. Yeah, it's like very yeah. Yeah, it forms nose like quicker and stuff. Yeah, but you ask people, it's very this whole thing I think is they were out of
So Team Atlas from Bangladesh are currently competing in the iSpace Space Resources task. You can see their base station crew. They've got a couple of RC controllers there, which they use to control their rover. So teams use a wider range of options to control their rover, which is really interesting to see what the different solutions are, what they've been practicing with, and what they've finally landed on. So they've got two controllers there. I believe one of them is used to control the rover's movement forward, backwards, and to turn. And then they've got a second controller there to move any additional actuators. So for the previous tasks in this challenge, for example, the post-landing, the Australian Space Agency post-landing task and the ELO 2 excavation and construction task on Thursday and Friday respectively, they would have had their arm attachments on the rover. They would have used that second controller to operate that arm upwards, back, left, right, and all the other joint movements that they can possibly do. The other solutions that I've seen, joysticks are very popular. They're relatively intuitive, especially if you get the operators able to practice with them, practice, to be able to get an intuitive feel for operating their rover just by seeing the video feeds that they can see on their screen. And then another option that we've seen time and time again is the trusty keyboard, whether it's on a laptop, on a computer, moving the rover using those keys is a tried and true method. So the rover is quite speedy. You can see quite nicely the track that the rover has used to make its way into that crater and then around to the front of those samples. Reminds me exactly of what wheel tracks on the moon might look like once we get rovers back on the moon. Of course, a couple landing last year on Slim had a couple of smaller rovers that landed from the Japanese Space Agency, which is very exciting. And of course, Chandrayaan-3 from the Indian Space Research Organisation, or ISRO, landing last year, descending from its lander and going to investigate the surface at a latitude of around 10 or 15 degrees from the South Pole.
I think I can go get a hat from them. Like the cap. Do you want a hat? They can go get one. It's a free one. Yeah. Can you? Yeah, I'll look.
But I don't remember when or how.
No, it was terrible.
I believe when So what were you doing again? You told me while I was there that
very, very late.
yeah, now it's clicking together.
But yeah, you're right. It'd be like, 3 kilos and operates.
That would be helpful.
this one we really do. We do like imaging. We just go, someone goes away, gets the imaging, and that's like 20 points right there. And then you can use it to come back. So yeah, we get 5 points for imaging, right? Yeah. And then you can do some analysis while you're trying to drill or something like that. And if you run out of like better than work, so you run out of things to do and you come around and come up the hand up. It'd be very good. It would just require like, yeah, you'd have to like double up your communication. No, you rate it with me as a whole. That's more like a yeah. Very good. I mean, I think Will is very good. Yeah. I don't really know. Yeah. I'd like to learn that. I've been trying to like yeah, because I'm chassis, so I'm like very hard to like kind of respect. So I'm like I can't even understand what's going on. It is cool, and I like the I like it. It's so fun to know that. Yeah. There's like there's those ones in YouTube, but there's ones that are like pretty better. I don't someone that's wrong, and then someone like just someone's size, I don't know, they're a bit more like, I don't know what it's called. Performance. Yeah, they're more like this is an art. I think it's still good. I know
Rất uống cái mà hơi gì ta tạo cho họ có chi bệnh này là chi này chia là chi năm chi áp lại cho chi này chia rồi nó nhiều nó cũng we all getting old now we can't remember everything we think
That was great. Yeah, that's why. Yeah. So they're like, you're smaller. But it is like, I would get like, I'm gonna give it a shake test. Yeah. So yeah, I got that.
So we've got Team Atlas from Bangladesh currently competing in the iSpace Space Resources task. They've got, I believe it will probably be about 15 minutes left in this task. So they're gaining points at the moment for going to our icy regolith sites, just under 15 minutes, sorry, and investigating them for water, for their water content, and also to our ilmenite sites as well.
Oh, it's even outside of this. It was very nice.
Yeah, just so that, you know, like, you get those at the end, just because then you're not going to accidentally, like, push it in the wrong way and snap
I
something.
think that's actually what it is. Yeah.
So, I think that's the main one thing we're trying to do something you want to do. And then after that,
Yeah.
things that you can do your chassis and you can
No, because I can't take multiple. If you go yourself, then you can get one. It's just the cats then. But they might think we look the same, so maybe not.
I don't know. I wear mine.
I don't know if it's like powder coating or something.
hồ luôn
I
được
did,
kia
like I didn't really notice, and then I looked at notes from last year.
whoever
Yeah, like I was very bright.
Ko ilu lai áp lu chỉ cái hết đang ra. Ở đâu đây? Nhang lai áp lu. Lu khử lu thổi cái khét ở lu kia, ở ba khử. Khử lắm. Cái lai băng gì? Này băng cái gì làm trò lu cái. Khử lên đây.
And go with Bug.
Not very good.
I think he wants a hat as well.
Yeah,
I definitely have doubts.
I think it's like I think you can do it, but I think
Like I like the yellow hat as well. And they said, oh, it doesn't have the logo, like the Australian logo.
as opposed to doubling up in new road. Doubling in new road is like very expensive.
Oh, yeah, no, I agree with that. I think the old boards are.
Yeah, or even a part of this revive.
Yeah.
Or I did try that. I wish we could do it. That's the other thing. Well, yeah.
I think if you want to stick with current steering mechanism we got, if we make a new one, you kept Morita, it would be very similar.
That would be
So
very
operators can train on both and get similar experience.
Yeah.
But I agree, not making too big. Unless we made like mini robots.
Yeah, that's So maybe I think they only make 2 years.
Yeah, that's
Last year, and it was very like it was like you double everything. You double your like if something goes wrong, you go replace it. You double the cost of that. You want to make a change to the new robot. You better double it. Yeah. No.
yeah, it's millions of dollars.
I think I used Chucky like 6 years on the new robot. I know. I've been doing that for people twice.
Yeah, that makes sense. This was just a spitball. Oh, you were there when they were spitballing.
Yeah.
Last night. Yeah. So they said they mentioned a couple of times how like an AI system was.
I don't know how that would work. I don't even understand. What was the application?
Just so then, in my eyes, that's just splitting the team. You're just gonna have 2 Rover teams, one that goes to America, one that goes to Adelaide.
Right.
Because the idea is that you can design more directly for the task, but I don't know.
Yeah.
I had 2 arms really, so the arm would be the same. 'Cause no one was building one arm.
Yeah.
Because the science stuff, we already built 2 payloads.
Yeah, and the reason we don't split team up for that exact reason is like then you have an ART. It never ever gets to
Yeah, to go to US.
Yeah, it has nothing to do for half of the design.
Yeah, exactly. I think, but that was it. Then you have a larger design cycle. You have a whole year to really define.
Oh no, it's
through
like outside in the
systems,
middle, so
half
it's
the
not in a
systems
specific
away
campus.
for URC.
They
But
make-
that could just be more organizational.
I think so. I think it's like just like more more realistic. And like I think we should blow out the numbers. Like, it would be very good. We would disagree about that. 2 year design cycle. Just like planning things. Like being
Yeah.
like this system is likely not to be done at once. Like that is very hard. And they're starting that.
I think they have to be something especially arms. Sorry,
Yeah.
I don't mean to brag.
No, it's
but
just like-
arms seems to be always perspective. Like, oh, that's going to take so long.
It's like outside, it's just
It's going to take so long. You should start it now.
You should start
So
and
then
push
it's
as much as you
years.
can. And then like
have it.
yeah, exactly. Yeah.
Because now we're at the point where it's like no one knows arms, no one wants to touch an arm, no one
Yeah.
barely wants to even maintain arms because they're scared of break it.
Yeah, it's like a full. It's cost of design change. Just like increases the more complex developed system. It's like to make a change. It's like you have to change. Like to make a change is very hard.
Yeah.
And then it's like very hard to justify it because you have so many things.
Yeah, exactly.
Yeah.
I know the arms slowly. And same with
So Team Atlas from Bangladesh have just under 7 minutes left in this task. You can see that the rover is still trying to maneuver and make its way around the challenge arena. You can see it moving there into the crater that we've prepared for them. And you can see their base station team there working furiously, operating the rover and doing their best to secure as many points for their team as they can. We've got 2 icy regular samples in that crater, which we've pre-prepared for them and frozen in our freezer on site for the last couple of days to make sure they're super hard, super cold. And that'll be a challenge for the next teams who are going to be drilling into those samples and trying to extract liquid water from them.
Of course, the higher the water content, the harder the sample, and so teams will have to make the choice between a higher concentration of water, but harder to deal with, harder to drill into, harder to extract, versus a lower water content sample, which might be a little bit easier to work with. Teams will get 30 points for extracting any quantity of liquid water at all. Hopefully we'll see quite a few teams do that today. We've had this task in the challenge for a couple years now, and no team has been able to extract any liquid water thus far. So I'm very excited to see which teams can. I have heard whispers from Project Scorpio, the Polish team who competed just before Team Atlas, that they may have been able to extract liquid water, which would be net them quite a few points. So the high concentration of water, low concentration of water that I was speaking about previously is also important because there are additional points for the volume of water that you can that you are able to deliver to the judges at the end of the task.
It's better to do it not when they're, when they're fresh out and they're still like semi-routine, not 5 years out when they're established jobs like, I don't really care about this anymore, I'm busy with work. I think that's the idea, is that especially around like often. So if we start talking about it straight after hours, and he's got so much knowledge, he's got the previous one that he was like, I feel like I'm missing someone. No, I don't.
So Team Atlas have just a few minutes left in their iSpace Space Resources task. They're going to be trying to net themselves as many points as they possibly can before that time elapses. And it really is a revolving door down here at our challenge arena because we have the University of Melbourne Rover team, or UniMelb Rover team, waiting. They've done their briefing over by the judges' tent. They're currently setting up in our other base station that we've got behind the challenge arena, and they will be coming to you from 10:30 a.m. local time. They are our next team up competing in this task.
I know, it's just like, I look at like science happening. I know that we're well covered there, crazy. It's just so out there that all the time that they're ready. I haven't seen I think the way to, I don't want to say force, but to make other systems improve is to time one more stuff. And like say the soccer side, I'm not sure they had a digital twins. We can't do that with us. We don't have, I don't think we started asking this yesterday. I was just getting very confused, but I think it was, we don't have position control, we have velocity control, and we have position. Oh, we don't have absolute position control. Yeah. It's like you need it.
No, it doesn't seem like that hard.
I think they're like something it's not as easy to implement without brushes and motors. They're really sure. I'm like, go back to the brushes. So I'm like, I feel like I've talked to a couple of like
the newer recruits are out, they're like, I don't really know what to put. Done the color, I'm like, I feel like that's a ton to do. Yeah, maybe just ask around. Because that would be a good one to do, because the digital tool.
So Team Atlas is still working. They've got only a few minutes left. They're doing their best to try and secure as many points as they can. They've got what looks like a pan and tilt cam, that white spherical object on that linear actuator arm on the front of the rover. We just saw that spinning around before, so they're trying to get a nice view of exactly where the rover is and what it's doing. Unfortunately, it looks like that arm has actually skewered into the ground and then is blocking one of its wheels and preventing it from moving. So we wish the base station team all the best. So they might not be able to know that this has happened because they only have access to the camera streams. Yes, you see it moving a little bit more there, and that arm is still skewered in the ground. So they're trying their best to remedy that issue and secure any additional competition points that they can. They've got just a little bit of time remaining on the clock. Let's see what they can do.
Is it? Let me see. Yeah, that's just to show that it's genuine. It says official product.
The same size, look like a same size.
Yeah, exactly. So it's like
Because it's the same like the one top.
So Team Atlas's time is quickly expiring, but please stay with us. We'll have the Unimelb Rover team on the Challenge Arena for their task at 10:30 a.m. local time, which is just coming up in a short 5 minutes time.
Why are you guys staying? Do you want to stay? Yeah, they want to stay for the whole thing. Ours isn't coming up till 11 something. Oh. Yeah.
Something. This is a group of it.
This is where it started. And where you start. This is where you find a top 100 university, world-class research, and these little guys. This is where you study crashes and become cancer smashers. This is where you crush it, cram it, glam it. And this is where you grow food. For space. This is where your time begins. Make history at the University of Adelaide.
hỗ trợ呢隻咧，我隻嘅電話好穩，都有啲時間叫啲貨爸爸嚟貨，呢個啲時慢慢佢好呢隻呢隻嘅。啲時賺我唔賺嘅，誒都係 friend 鋪咯。đây thì bộ cơ cả thì cho được cái loại ở team làm sao lại team
Oh, it's so crowded.
Okay. Bây giờ team thì có một thời kỳ. Bây giờ team thì có một sao.
And because my friend left her bottle here, I don't want to leave it.
Cái ly nó xây dựng, cái ly nó cái xì, cái ly nó cái xây dựng, cái ly nó cái ngon nhát của.
Oh yeah, Kevin says he knows some people in the team as well.
Yeah.
So, welcome back to the Australian Rover Challenge Day 3, 2024. You're joining us for the iSpace Space Resources task, and on the field currently we've got the Unimel Rover team. Their time has started just a couple of minutes ago. They spent some extra time making sure they're all set up. The rover is ready to go, and it'll start the task very shortly. In this task, they have three primary objectives. The first objective is to go over to our icy regular samples and try and determine what quantity or what content of water is present in those samples. You can see the rover has left the start line there, and it is on its way towards the first sites. So there's 20 points available for heading to each of the sample sites that we've laid out on the field. There are 2 ilmenite samples and there are 2 icy regular samples there.
Yeah, you do. Where's that one? It says video.
Yeah. Cậu ốc về cái red thì mua đúng không?
Yeah.
Đây còn nó mò mua.
You gotta press the red one.
Cái red one.
So you can see the base station screen which the operators are using to navigate the rover at the moment. They've got quite a unique design. You can see on the top right there, we've seen a top-down view of their sort of snail-shaped spiral excavator there, which is going to spin on its axis and try and collect some of the icy regular sample.
Right now, they're just lining up to one of the ilmenite samples that we have out on the field, and there'll be points available for determining what content of ilmenite is present in that sample. The team will have to relay that information to the judges in the presentation, which will take place shortly after the conclusion of this task. So there's a close-up shot of that regolith acquisition system. So if you can imagine from looking at it here, that will I imagine that will lower to the surface and then rotate clockwise to then pick up a sample using the open section of that mechanism, which is about in the 2 o'clock position as we're looking at it there. Of course, they're over the ilmenite sample at the moment, so they won't be using that mechanism. But I imagine they'll be using it once they head out to the crater, which we have on the field, and trying to use that to collect the icy regolith sample. Once they've collected it in that shape, they'll be aiming to transfer it to their processing mechanism, and they'll do that by backing out that shape by rotating the mechanism the opposite direction. So an interesting option that the teams have this year is to actually have their processing plants off board. So behind our own processing plant that we have on the Challenge Arena, the University of Melbourne Rover team actually have their own processing plant, which they would deposit their regolith in, their regolith sample in. So you can see it in the shadow of the processing plant there, just underneath those tanks on that cache there. So the teams were able to choose their own option, whether they had that processing plant on board the rover itself or on the surface in another location of their choice. So the whole system still has to be under 50 kilograms, as with some of the other tasks. And this is to simulate if potentially the processing plant or the rover has made it to the lunar surface at separate times. So there is definitely a chance that in future missions, we might have a rover that's able to survive the lunar night and maintains its functionality for a long period of time. And then maybe a processing plant to process icy regolith out of acquired samples might be landed on the surface at a later time. So I think it's actually quite a strategic decision that the team has made here. They've put their processing plant in the shadow of our processing plant, like I mentioned before. And I believe that's probably due to the fact that they will need to condense the water that they're acquiring and then processing. So you can see the Unimel Rover team has made its way into the crater that we have at the back left of the Challenge Arena this year, and you can see there's 2 placards in front of the rover there, and they're designating our 2 icy regolith sample sites, Site 1 and Site 2. So each of those sites, I don't know which is which, I haven't been told. They have a different quantity of water in them. One has a high quantity of water and the other has a smaller quantity of water. So the teams will have to try and determine which is which, and then they have a choice to make. They can either go and try and process the site which has a high quantity of water, which is going to be a lot firmer, almost as hard as ice, or potentially even harder, and try and process that for liquid water. Or they might choose to go for the site which has a lower content of water but might be easier to deal with. There's 30 points up for grabs for processing and presenting the judges any volume of water whatsoever. So it's quite a lot of points are available just for that. And then an additional 20 points available based on the volume of the water that they collect. And obviously going for the higher quantity of water sample will be advantageous in that respect.
So you can see the base station team in the bottom right there. This is what they're seeing on their camera feed. This is the only information that they're able to use to determine where their rover is, whether it's lined up, and whether they're ready to execute their different processes and different tasks. So you can see they've got what looks like 5 available streams, all of different angles, which they'd be using for different purposes in different for different purposes, for different ways throughout this task. So you can see, whilst it might look obvious from being here in person what the rover needs to do to line up with a sample or be able to maneuver through a gap, it can be very difficult to do this just looking through those screens. So you can see on the right-hand side of the front of the rover there, they've got some sort of probe, and they'll likely aim to put that into the sample to then determine what water content might be present within it. So these probes, if it is what I think it is, you can see it just retract up like that, which is very clever design. It's obviously on some sort of servo motor or something like that. So if I'm correct that it is a hydroprobe, I think is what these instruments are called, it's essentially measuring the conductivity of the material that it's placed in. And normally the higher the water content, the more conductive the material is. And then you can correlate that with exact numbers if you calibrate the instrument, which they might have done before the rover was fielded today.
Weź, robisz tę kamerę, nie możesz mi tak powiedzieć. Bo ciebie postarali się nie zaprzeczeć. Niemiło.
So we saw an image just from before of the base station team. So it looks like they're strategically thinking about what their next move might be. So you can see them there in front of their computer screens, pointing, wondering what to do. They've got quite a number of members in there, which is always good to have to be able to, get different ideas, different opinions, and try and figure out what the best next move might be. I can't emphasize enough how complicated these rover systems are, the amount of integration that goes into them in terms of mechanical, electrically, software. There's so much
much to do, and all of this information is available to them, and that's all they have to make decisions on the fly and figure out what the best decision is based on the current state of the rover, where it is, how it's operating, and no doubt, normally something doesn't go to plan. Something's happened, and so they have to figure out what they can do. So you can see that they've lowered that probe once again, which is it's got a yellow top, which is just slightly obscured by the white sort of spiral bucket scoop there. And I think they'd be lowering that into another one of the samples to try and determine the water content of that second sample.
for caterpillar. You get that for caterpillar.
Maybe. Is that one of them?
Caterpillar.
Thank you for shortcut my water.
So it looks like the rover has done probing both of those samples. Hopefully the team in the base station have an idea of the relative content of water within both, and then they can go ahead and make a decision, and you can see them there deliberating, debating what they might do next. So do they go for the high icy content sample, which might be hard to deal with, try and get as much water as they can? Or will they go for the one which is easier to deal with? So a reminder, there's 30 points up for grabs for generating any water, any liquid water whatsoever in this task. And then there's a further 20 points up for grabs for the volume of water. So there are definitely challenges, advantages, disadvantages with both. So I'm very lucky now to be joined by Jasper, who's actually on the UniMelb rover team, so that we can run through exactly what's happening out there and get a bit of an inside look into what's going on. So first of all, Jasper, can you introduce yourself and let us know what you do on the team?
Thank you. Yeah, as I said, I'm Jasper. I'm wrapping up on the team now. I'm departing after this competition, but I was part of the coordination team this last cycle.
Awesome. So, what does the coordination team actually do? Like, what's involved? What are your tasks and things like that?
Our role is to make sure all the other teams, play nice, work together, and hopefully make sure everything can integrate at the end of the cycle, ready for competition.
Cool, awesome. So, I'm wondering if obviously you're not in the science team, you haven't built the system which is currently on the rover. I'm sure you have a pretty good overview of what is on there. Was I right with, is there a hydroprobe which is testing what the water content might be, and then that bucket drum, the white circular thing, is that going to be used to collect one of the samples?
That's certainly the plan. So as said, there's a black hydroprobe which is ideally going to be pressed into the sample and measure the content of water based on the conductivity. And then once we pick the sample we want to excavate from, we'll raise the probe up and drop the scoop, and it should scoop the sand up, and then as it rotates, the sand will be kept inside and won't come out. We also have heating elements which we're going to apply to the sample before we scoop to try and melt some of that regolith, and so we don't have as much difficulty extracting.
Yeah, awesome solution to that problem. Like I've been saying, that the high water content sample is going to be really, really, really hard. And so there's actually a mission which is headed to the moon. I'm actually not sure when it's slated for, but Viper is a NASA mission which is going to try and drill into some icy regolith samples as well. And it has a really massive drill on it to try and penetrate and get through that hard sample. So heating up the sample before is a really cool solution. I noted before before, you guys have opted to go for the processing plant separate to the rover. Can you first outline, if you know, why you guys made that decision versus having everything on board?
Definitely. I think we decided to go with a separate processing system to try and ease the space constraints we have. Last year, we obviously had to try and do everything inboard, and we were very constrained on space. And so getting some extra space to do processing, while it adds additional complexity of depositing the sample, we thought would ease our issues with space on the rover.
Yeah, great idea. Like you said, it can be really, really, really difficult integrating all those systems together. And if you can have that science, that specific team, just focusing on that one standalone sort of payload, that can make it quite a lot easier to deal with, which is really cool. So we were just talking through before, there is a rule which allows teams, if their collection mechanism isn't working, but they are able to produce liquid water from the sample, they do have the option to manually load their processing system with a sample that they collect from their field team. Of course, comes with a bit of a points penalty. So, Jasper, can you walk me through, is the team intending on doing this? Are there any other challenges that you're facing out there with the processing to get liquid water?
We're facing a lot of challenges, as is the intention of the competition. I think at this stage we're hoping to not need to use the manual loading. Everything mechanically seems to be functioning. Unfortunately, this is a new system, so we don't have a means of testing how much excavation has occurred and how much of the sample is in our scoop. And so I think we'll see that base station's going to try their best, and if they can't confirm that they've got some sample there, they might have to go through a manual loading method. But I think that'll be up to them. We're going to struggle, I think, because of the newness of the system. It's kind of a fresh idea. We've taken ideas from last year, but none of it's really carried over directly. And so hopefully in the next year we can kind of address some of the solutions with an iterative approach, and we'll be more likely to be able to use the full system as intended.
Yeah, awesome. Like you said, it really is important to get that sort of base foundation in place. And then once you're able to iterate over that, you're then able to, just build capability and get better and better with each year, essentially, which you guys have done. This is your third year competing. It's been awesome to have you guys here. And hopefully you can continue to just go up and up and up. So, yeah, thank you very much, Jasper, for joining me. Wish you all the best. I think you guys have just over 18 minutes left on the clock. We've saw images before of their scooping one of those samples. So best of luck with the rest of the task today, and then best of luck for the rest of the competition.
Thank you.
Yeah, they're in the tent. Yeah, but it was at the university. I'd stay for the whole thing. No, I think it's the same thing.
So I've just spoken with the Unimap rover team, and you saw them excavating from the ilmenite sample there before. So it wasn't exactly what I said previously, and I've just spoken with the team, and they've let me know that they are in fact using the excavation system on the front to grab some of that sample, which they'll then use to measure the ilmenite content within it. So some teams have previously just used a probe or a visual approach, and they are actually collecting a sample to then try and measure it with potentially some onboard systems or onboard sensors. Like I mentioned with Jasper just before, we do have the option in this task to manually load their processing plant. Their processing system, which their rover is maneuvering to at the moment. So if they weren't able to excavate from the icy sample, they can manually load this into their processing system for a points penalty. So the rover has made it up to their own processing system and is trying to deposit that sample into their processing unit. The base station team might make a call later on if they are choosing whether to manually load that sample or not. You can see them there pointing to the screens and trying to figure out what their best next course of action may be. So you can see their processing unit on the right-hand side of the image there, which wire management obviously wasn't one of their key requirements. I'm sure they may have knocked this up just recently, but hopefully it functions exactly as they intended it to do so. It looks like the rover is actually mounting its own processing unit. I'm not sure if that is the intention. Like I said previously, it can be really, really difficult to gather spatial awareness of exactly where the rover is and what's around it based on just the few images that the base station operators have access to in the base station. So the Unimap rover team is doing really well in this task. They've made it around to all of the different sites. So they would have gathered quite a number of points from doing just that. And they have just over 10 minutes remaining in the task to try and muster as many more points as they possibly can. So I have been notified, I believe that the Unimap rover team will be going for a manual loading of their processing plant, I believe. So
in a few moments here, you might see one of the Unimelb Rover team field members jumping out there with another sample of the icy regolith that we have prepared, and they'll manually load this into their processing system. And then they'll hit go on their processing system and see if they can get any liquid water out of it. So they will receive a points penalty for this. However, as the competition organisers, we wanted to make sure that all teams had access to try and demonstrate these novel technologies and new systems that will be demonstrated on the moon in the near future. So whilst they weren't able to get that excavation, extraction, and then deposition system into their processing plant up and running, they will be able to manually load it and then try and process that sample for liquid water. And they'll still get quite a number of points for doing so. So like I mentioned, the Unimelb Rover team, field team are now have made their way onto the surface, and they're going to opt for a manual loading of the icy regolith sample. So we're going to give them some time to do that. They've got just under 10 minutes left in the task, so there's still plenty of time. They're going to try and add that sample to their processing unit, and then hopefully they're going to give the judges the all clear, step back, and then they'll be trying to process that sample for liquid water. So you can see on their processing unit, they've got some sort of drawer mechanism, which they will be loading the icy sample into. And then I imagine they'll be closing that back up and using some sort of extraction technique to generate liquid water from that sample. So again, it's not as simple as just melting that sample and draining the liquid water out. The water and the regolith, which is that lunar topsoil on the moon, is really combined. It is essentially one in the same thing. And so melting it won't really get you anything. It might get you a slurry or like a sort of like a muddy mess. But you really need another extraction technique, whether that is evaporating all of the water using heat, and then condensing the water to turn it back into a liquid. So the team is working as hard as they can, preparing that sample to manually load into their processing unit, and then it will go and whir away to try and generate them some liquid water. So I've just heard some calls from the team to clear the field. So it looks like they're all done with that manual loading process. They've done a fantastic job getting that all done.
and then we'll cross our fingers for them to see if they can produce any liquid water out of those samples, which will net them quite a number of points. In the meantime, we've got the University of Adelaide Rover team setting up their base station, and they'll be coming on right after Uni Melbourne Rover team are done. They'll be starting their shot at the iSpace Space Resources task at 11:15 local time, which is just over 10 minutes away. So you can see on the clock, the Uni Melbourne Rover team have just over 5 minutes left. They are working as hard as they can. They're moving the rover away from the processing unit, and the processing unit will be trying to generate liquid water from the sample that they just.
It's okay.
No, I'm not.
So you can see the base station team there working away on the laptops, ingesting that data from their processing plant and hopefully producing some liquid water.
So the Melbourne team has just over a minute remaining. They've made their way back to the icy regolith sites. So it looks like maybe they're going back just to confirm their previous results, where they're going to try and determine what the water content in that sample site was. So you can see that some of the instruments at the front of the rover there have made their way down to the surface to try and determine what that content might be, and then they've just raised back up so that the rover can maneuver again. Got a great shot there of the suspension linkages of the Unimel rover. So they've got some, there might be some anodized gold parts, gold in color, not in material, I imagine. I'm not sure that the Unimel rover team budget stretches that far. Pocketed CNC parts there making up their suspension linkages, which is a bit of a unique design that we haven't really seen in any of the other teams this year. So it's cool to see that maneuver over the landscape that we have. So time is almost about to expire. We'll confirm with you the scores once we're able to, but just a reminder that the team will be heading to their iSpace Space Resources task presentation shortly after this, where they'll be able to secure some more points. So I believe their task time will be ending very, very shortly.
And where you start, this is where you become tomorrow's
cyber expert,
physiotherapist,
CEO, or musician.
This is where your time begins. Make history at the University of Adelaide.
The universe's newest city is home to 1,000 people. And every year, over 10,000 come to visit. Only 20 years ago, this city didn't exist. It's the result of pioneers sending rovers, then discovering water. The hydrogen and oxygen separated from water becomes energy, creating the foundation for a fuel station. And with the fuel station came scheduled flights, followed by settlers. Soon, settlers required more diverse skills, attracting new specialists for construction, steel, communications, energy, transit, agriculture, medicine, and more. People travel from far and wide to see this new city. We call it Moon Valley. The moon is the new staging ground for your next level business. Expand our planet. Expand our future. iSpace.
So welcome back. If you're just joining us, my name is Henry. We're at the day 3 of the Australian Rover Challenge, and we've got the University of Adelaide rover team is currently readying their rover on the challenge surface just now. Their task time will start at 11:15 local time, which is just in a second. In the meantime, I'm joined by Sophie from the Project Scorpio, the Polish team. So can you please introduce yourself and just let us know what your role on the team is?
Yeah, sure. My name is Sophie. I'm the team leader of Project Scorpio from Poland. Normally I work with marketing and business department, but it's everyday role, so you'll help where you can.
Yeah, awesome. So, like so many of the other teams, everyone pitches in, everyone does a little bit, and all of that. So we saw Project Scorpio were up first today in the iSpace Space Resources task. You guys were sitting first on the leaderboard before that. We're still confirming all the scores from the water extraction and the presentation afterwards. But can you run us through? You're in the base station for the task. Can you run us through, from your perspective, how the task went?
I think it went very well. Everything was working as it should, which is very rare for the rover teams. But everything was working as it should. The team was working together very well, and we are very positive about the score.
Yeah, that's awesome to hear. Like I've said so many times over and over again, these systems are so complex, and you had a whole new processing system on the front of the rover. And so to be able to change that in and out and then have it all work seamlessly is an amazing achievement. So congratulations for that. Can you outline some of the challenges that the team has faced either this week or maybe in the lead up to the competition? Just outline some of the challenges you guys have faced.
Sure, I think for us it's a bit different than for other teams because we travel so far. So the logistics alone is quite a challenge, but we're used to it. Other than that, mostly the soil is different than in Australia, and the ilmenite, it's very rare in Europe, all over the Europe, in Poland especially. So we got 5 grams of ilmenite for testing, and we had to pull it out with the magnet every single time. We had 5 grams, and we had to give all of the 5 grams back.
Yeah, wow, that's definitely quite the challenge. I think we've already spoken with myself, the other competition organisers, to try and make the ilmenite a little bit more accessible to the teams, particularly the international ones, in the future. But that's astounding that you guys were able to manage that and deal with that. Yeah, awesome. So can you tell us a little bit about what's coming up? So you've got the mapping and autonomous task tomorrow. Are you guys hanging around after the challenge or anything like that?
After the challenge ends, we are having 2 days for ourselves in here. We have to pack up everything and we want to do some sightseeing, of course. However, after the task is ended, for now it's all work. But we're hanging around today, around the field. We want to do some testing afterwards, so I hope to see you soon.
Yeah, awesome. Once again, thank you so much to you and the team for joining us. I know also you guys have last year enjoyed the native Australian animals that we had on site. And so for everyone in the audience today, we will have the native Australian animals back again today from 12 o'clock until about 3 p.m. Over in the team's sites over on the grassy area over there. So please go and enjoy them. Hopefully you guys have a well-earned break after the competition, and congratulations. I'm really excited to see how it all shakes out with the scores today and tomorrow.
Thank you so much.
No, that was Melbourne.
Myślałem, że to jest moja. Ty nie byłeś ten kolek, do wstawały. Ja wiem, że rodzice ale skoro 8. Ale ja nie patrzyłem na to, czy jest gradów, czy nie. Ale no jest Igor, tu pisałem. Kurwa. Nazywałeś kurwa koszulkę? Nie. Nie, patrzyłem na Rover czy koło jest prawie. Nie było mnie właśnie dawka nawet. Byś się nie pomylił, bo jest na dole.
Dobra, spoko, idziemy tu. Mamy zakres rozmowy.
So you can see the University of Adelaide Rover team is currently readying their rover on the challenge surface, trying to get ready for their attempt at the iSpace Space Resources task. They'll be the 4th team attempting this task today, where they'll be trying to analyse and process 2 icy regolith sample sites to try and produce some liquid water. They'll also be analysing some sites containing ilmenite, which is a mineral found on the lunar surface. And then lastly, they'll be hosting a presentation with our specialist judges where they'll be talking to them about what they believe the contents, the mineral content and the water content of each of our sites was. So it looks like the field team has cleared out and the rover is on the start line there. and so they'll be getting ready to operate very shortly. I think we'll expect it to be moving in the next couple of minutes or so once the base station and the operators are ready to get on the move.
Where's the Rover?
I haven't, no. Not since in the tent. There we go.
Great. See him, let him know I'm looking for him.
Will do.
So teams have 40 minutes to complete this task. The time has started for University of Adelaide, a Rover team. I'm sure their base station team is just making sure everything is ready to go. Their communications are solid, and they are prepared to essentially drive around to the sample sites and analyze them for their water content. So we've got some members from the University of Adelaide Rover team joining us in the audience today. So they are watching over their team compete today. I'm sure they have some other roles. They've been busy behind the scenes making sure their Rover is ready to move. You see some live shots of their base station team there. So they're just making sure that all of their screens are showing the right thing, all their video feeds are sorted, and then I'm sure they'll get underway. Like I've said before, the teams have different methods of controlling their rovers, and it looks like the University of Adelaide Rover team has opted for an Xbox controller, which you can see just behind that water bottle there. So it's a good intuitive way of being able to control the position of the rover. So I can't understate how important these tasks are for the teams. They are developing new critical technologies that will be required in the next decade as humanity goes back to the moon, hopefully to stay. So essentially, we do believe that there is water near the poles of the moon. However, we haven't been able to take any what's called ground truth measurements. So that's measurements from literally on the lunar surface of the quantities or types of water. And when I say types, I mean how it's bounded in the material, whether it's chunks of ice or whether it's in the cracks of the material or sort of locked up between chunks of material there. So the teams have been developing these novel systems to try and excavate that icy regolith and then also process it for liquid water, which is going to be so important when humanity does reach it back to the moon, because they will need that to produce hydrogen and oxygen and liquid water, of course, for drinking, oxygen for breathing, and then you can also use the hydrogen and the oxygen as a rocket propellant. Producing that material on the lunar surface in a process we call in situ resource utilization, or ISRU, means that you don't have to take that massive rocket propellant with you from the Earth. And that means that you can add much more mass of the important stuff. The instruments, the equipment, the science, the landers, everything like that can have more mass instead of just being tied up in fuel which you're going to burn. So the base station team is still working as hard as they can to resolve any issues they might be facing. They do have some options available to them if they aren't able to get the rover operating as they intended. Like I've said previously, it is so hard to get these systems working. An integrated system like this with a new payload to get communications reliable, all of the motors working, all of the sensors working that you need to be able to control something this complicated. So if they're unable to do that in this task time, what they can do is elect for what we call an intervention, which is going to be the base station team can say, hey, we don't think everything's right. We want our field team to go out there and have a bit of a look and then determine what the best next course of action might be, make any repairs as necessary, and then hopefully get on underway shortly after that.
There is support there, but that's understating how difficult it is in another country. Children make
So it looks like the team has been able to troubleshoot their issues, and the rover has begun traversing across the challenge arena, making its way potentially over to those ilmenite samples which are near our processing plant.
Numbers 1 and 2 are actually behind the sand dune over there.
He had a problem.
Very exciting to watch. Yeah, have a look at it.
So awesome work to the University of Adelaide Rover team base station operators there, diagnosing those issues, troubleshooting, and then getting the rover underway. So you can see they've got their space resources payload on the front of the rover there, which will likely be trying to analyze those samples for the different mineral contents that are present. For example, the ilmenite that we've placed, that we've enriched in these samples, which is a critical mineral found on the lunar surface, which might be important in the future for things such as 3D printing or building other critical infrastructure.
Oh, the name, yeah, well that happened too.
So you can see, just like real space missions, it's always handy to have quite a number of people in the base station. Some people on the controls operating, but also a number of people, analyzing the information, digesting it, and trying to figure out exactly what the best next course of action is. So like in the control stations that you might have seen at NASA or some of the other space organizations, they'll have different roles, different responsibilities, and they'll all try and be working together to figure out what their best course of action is to maximize the number of points in this task. So the rover there is approaching the 2 ilmenite samples that we've marked out with those little triangle placards there. The actual samples are sitting just in front of them, and so the rover there will be able to, they'll get some points for imaging those sample sites right there. So 5 points for each of the sample sites. So you can see the rover is approaching one of the sample sites. It's likely that they'll have some instrumentation on the front there, and they might lower some sort of probe or other instrument into the ilmenite to try and determine what the ilmenite content is within that sample. They've also got some sort of red shade. Well, it looks to be, which is flapping around a little bit in the wind that we've got here. Obviously, no wind on the moon, no atmosphere, no wind. So that would be absolutely very sturdy, dead as a rock on the lunar surface. So my hunch is that red shade is just being used to shade and cool the objects behind it. So when the team moves to the icy regolith samples, which are in our crater in the back left of our challenge arena, it'll be important to keep that device really cool so it's able to condense any of the liquid water that it is able to produce and then potentially evaporate. So that temperature differential between the hot to evaporate the water from the content from the sample and then the cool to then condense it again, just like how you get water condensing on a cold glass of water in a hot summer's day, will be their approach here. And so we've seen other teams using ice packs and other things like that to keep those condensers really cool and maximize the amount of water that they're producing out of those instruments. So there are many different ways that teams might choose to determine what the ilmenite content is. So one way is visually. So we've seen cameras being zoomed in really close to the surface and trying to see, because you can visually tell the difference between the normal surface that we've got here, I think it's basaltic or quartz-based sand, and the really dark, fine ilmenite, which takes the space in between the larger sand particles. So I'm sure the team is just weighing up their next options. There's still a second ilmenite sample site just to the right as we're looking at it, which if they go and image, they'll be able to get themselves another 5 points.
What they're doing, you guys, but the first day, which is one of the agency sponsors, they've got to go around and read the signs, so you can see the black and green lettering. They've got to go up and be able to read that back to us. And there's a QR code that they have to go and scan, and they have to turn the knob and switch the buttons over on the machine. There's one umbilical on the lander and one umbilical over there that they're trying to connect, and they have to read at the base station at the back. So they're all over and moving around a lot more. I've got a lot of ideas, but it does require sample
I just feel like Lachlan never gets to realise. I feel like if he just stepped back and let it record, he would have done in this class.
You think it's done? Yeah. We've been talking to technicians, organisations, but Amelia then sort of because I didn't just go walk. I'll see you
Anything associated with it, yeah. So how long is the space coming
I don't know if they're having fun. They'll decide fun afterwards. You play soccer, yeah? It's a lot of fun to play soccer. That's what they're trying to do in the tennis. And the big games to play a soccer team is a lot of people. Yes, it is. One of the tasks they have to do is touch them.
this year? Yeah.
Go through and press it. But with a robot arm. So that they don't type that message directly, but there's you see a little white square at the bottom left-hand corner of that. That's a little card that you scan, and then it pops up on the screen into the control room and says, type this into the control panel, and then they have to go and type it on the first day. Yes, you have to watch the camera and then it gives it back. Yes, you have the. If you don't, there's a lot of lines like that, so it's not very complex what they Yeah, absolutely. No, it's not a sterile zone. As you never go to cables. Sam. Yeah, so John's sitting.
So, if you're just joining us, this is the iSpace Space Resources task at the Australian Rover Challenge. We currently have the University of Adelaide Rover team currently on the surface competing. So, there are three main components of this task. The first component is to head over to our ilmenite enriched samples that we have over near our processing plant, and you can see just by the centre wheel of the Adelaide Rover there. The Adelaide Rover's moving, potentially making its way elsewhere on the field. So the team will get points for travelling to those ilmenite-enriched samples and then also telling our judges what content of ilmenite is present within that sample. The second component is to do with our icy regolith samples. So this is regolith, like the moon, the lunar dirt which is on the moon, which we've then added water to and snap frozen in our freezer to make it really hard and compact. And so those samples are present in our crater, which is in the back left of the challenge arena, which is where the University of Adelaide Rover is heading right now. So there are two samples there that you can see marked out by the two little black markers in the bottom of the picture.
And so the goal for the teams is to try and produce liquid water from those samples. So they'll have to take on board some of the sample and then analyze it and determine how they can get the liquid water out of it. So a common approach here is to essentially evaporate the water from that material and then recondense it as a pure liquid and then provide this to the judges. So there are many points available for this. There are 30 points out of a possible 100 for this task available for collecting any volume of liquid water or whatsoever. There are then an additional 20 points available for the volume of water that they're able to collect. Teams have 40 minutes to complete each task. And you can see that the Adelaide Rover team has just over 15 minutes left.
There are a lot of things that we've lost. I've seen wheels fly off. Some people don't even get on.
The Rovers are controlled from their base stations, and you can see that they've got operators there looking at their camera feeds, and that's all the information that they're allowed to see to be able to control their rovers, just like they would do if the rover were on the moon.
It's interesting actually, the Queensland team was to this, and they had it mounted on the first rover, but then they went over and they took images from the site so they knew when they were doing the thing properly, and so using two rovers to make sure. So the other one was just a little bit yeah. It needs your own little rocket engine. Makes it a very loud, expensive rocket, but probably a lot of money. They're talking about next year being but that's see. I don't think they would do that to the film because that would be quite difficult. There's an yeah, absolutely. I don't know if these things they've got a little rover, and they're basically sonar for using light, but for nothing. So they can show you live how that's mapping everything around the sonar and how you can drive it. So it's using that. Yeah, they're behind the big hill at the moment, which is why everyone's looking at it. So they do, if you want to see all the productions, you can see here. Don't worry, I get up and walk around and definitely do not see all of yeah, well, I don't obviously don't have a team. I was on the judging for the first day, so I'd be very impartial. But, so that's the you guys want to go down and have a close, we can't get.
So you can see the Adelaide University Rover team, University of Adelaide, sorry, Rover team has made its way over one of our icy regular samples. Hey Tommy, can you move to your right a little bit? Tommy? He can't hear me. So the University of Adelaide Rover team has just over 11 minutes left in the task. They've made their way over to the crater which houses our icy regolith samples, and so they're going to be trying to analyse those for their water content, and then if they're able to excavate a sample from there and try and process it to produce liquid water.
He probably doesn't know that. She also probably doesn't realise that I've been up with her about water. How to deal with it 3 days.
So remember, there are a couple of points available for just making your way to the sites that we've marked out, which it seems like they've done. And then there'll be additional points available for determining that water content and then processing it for liquid water. So the team has, I think, just under 10 minutes left to go. In the meantime, I'm joined by Pat from UNSW Canberra. So yeah, Pat, can you introduce yourself and tell me why you're here and what your role is?
Yeah, absolutely. So I'm Pat. I'm from UNSW Canberra, currently 3rd year of an aeronautical engineering degree. We're looking at entering a team into the competition next year. So myself and 2 others have made the journey down to have a look. I'm the team lead as well as the chassis lead for next year. It's been awesome fun.
Awesome. It's fantastic to have you guys here. You can learn so much from being here in person. We write the rules, we try and make them as solid as we can, but being here really does absolutely change it. We're always looking to increase the number of teams as well. So if there's anyone on the live stream who's an undergraduate or even a postgraduate student at a university that wants to join a team, please get in touch. We have a contact form on the website. So just wondering, so how's your experience been so far? What is some of the stuff that you've learnt from the other teams?
Yeah, so it's been amazingly helpful being here this year. All the other teams have been so kind, so helpful. We've been amazed at the generosity with information they've been able to share. It's been really helpful for us because a lot of the big decisions now are such fundamental ones, 4, 6 wheels. How are we going to design the chassis? What kind of communications equipment do we need? So it's been really helpful being able to come here and see what these teams use, see what works, see what doesn't, which is a big part of it as well. And it's just been great for us to lay that foundation of what we want to achieve. And so I think we should be able to have a fairly competitive entry next year.
Yeah, awesome. So I've really appreciated speaking with you guys. We're always looking to get more teams involved. I think you guys are going to do fantastically. So a lot of different design decisions that you've got to make, like you said. 4 or 6 wheels was one you just said. A fun fact from when I was at the University Rover Challenge back in 2019, San Jose University from the US, they actually have 3 wheels. Yeah, right. So don't rule out any possibilities. I would like to see 3 included in the trade with 4 and 6 as well. But what are you leaning towards if you don't mind sharing between the 4 and the 6 wheels?
Yeah, so based on the information we've been able to gather today, we're leaning towards 4 wheels. I think that seems far more simplistic in terms of power draw and current draw, as well as a lot of the more open source ROS packages seem to have that native support inbuilt for 4 wheels as opposed to 6. I've seen some funky 4-wheel designs though. The West Virginia University and the URC, their system acceptance review video for next year, they've got some weird they've got 4 wheels, but they've got prongs sticking out of each wheel. It's a very funky design. I think we'll stay away from that and keep it pretty simple, but yeah, 4 wheels.
Cool. Awesome insight into hopefully what will be, the first UNSW Canberra Rover coming to the 2025 Australian Rover Challenge near you. So, awesome to have you guys here. Ash and Shelley, awesome to have you guys here too. Shout out to you. Shout out to everyone from UNSW Canberra who might be joining us on the stream at the moment. Looking forward to meeting you guys in person next year. And thank you for joining me.
Appreciate it. Thank you very much. It's great to be here. Thanks for having us. Yeah, all the best for the rest of the day.
Awesome. Thanks, Pat. So you can see with just over 5 minutes remaining, the University of Adelaide Rover team has made it to one of the samples, and it looks like they've positioned one of their instruments just over the sample container there. So their instrument has, you can see in the middle of that picture, they have a really, really large auger drill, which has a hollow core, and they're going to use that to drill into that really hard and icy sample. So I'm not sure, I think I can still see a little bit of daylight between the sample and that drill. So it looks like the team were just jumping out onto the field there, potentially calling an intervention to just check on the health of the rover there and whether they can proceed or not. The team has just under 5 minutes remaining. Don't go anywhere. We have Monash Nova Rover from Monash University starting the iSpace Space Resources task at 12 o'clock midday local time. So that's coming up in just under 10 minutes. And they're currently sitting in second place before the scores from today. So they're not one to miss. Project Scorpio, who went at the start of the day, they're currently sitting in first. And then we'll get some additional scores to you updated to the website and onto the leaderboard as soon as we can.
It's where the robots fight each other. The best team. Yeah. Remote control. Fighting each other. What you see, if you do stand on the side of the sand over there, so you can't go into the main thing, you see that so pushing a lot of sand is super difficult. That's exactly. Pick it up and then carry it. Yeah, absolutely. I mean, you can.
So the University of Adelaide Rover team here has opted to go for a very large drill and heater arrangement, which they've chosen because of the hardness and how cold that icy regolith sample is. That's just one possible solution. We heard from Jasper from the Unimelb Rover team just before that they actually use a heater. You can hear the team applauding there because you could see the auger rotating there and hopefully collecting some regolith.
So you can see them drilling, like the thing spinning.
You can see it drilling into the sample there. And so that's the beauty of the Rover Challenge. We have 10 teams competing this year, up from 3 in the first year, 5 in the second, 8 last year, and now up to 10 teams. And hopefully, like I just spoke to Pat from UNSW Canberra before, hopefully we'll have even more teams next year to just continue making it the competition more and more fierce. So all of the teams have a unique and different approach to each task and each challenge they have to overcome. And boy, are there quite a few of them. And so whilst the Unimelb Rover team opted to melt some of the surface of the regolith, the University of Adelaide Rover team has opted for a really high power drill, which they've been able to fit within the size, weight and power constraints of the challenge and of the task.
Yeah, so in one of these stands, you have to really these guys are going to be yeah, I'm so sorry he was Bangladesh. He didn't see that they were very they're the ones that are watch. These are fun.
So there's just over a minute remaining. The Adelaide team is obviously working furiously behind the scenes to try and collect that sample and then process it for some liquid water. Wish them the best of luck, because like I said before, there are 30 out of 100 points for this task available for producing any liquid water, any volume whatsoever.
There's no requirement on that. Maybe that's something we could do next year, that they have to extract it and then strain it. They have to process it. From here, come in. Yeah. That would be nice. I don't think that's what's going to happen. We should take care of it by the tree. I don't have any gravity to keep me out, so I just need to
So it looks like that is the end of the task time for the University of Adelaide. Let's give them a round of applause. Fantastic work, guys. And best of luck for the point scoring.
So, welcome back to the third day of the Australian Rover Challenge. My name is Henry, and you're joining me for the iSpace Space Resources task. Up next in the task, starting in just under 2 minutes, we have Monash Nova Rover from Monash University. They're currently sitting in second place for the challenge. Their rover is at the starting position. The judges are just finalising the resetting of the field and putting our samples out there for them to navigate to, analyse and process. So this is the iSpace Space Resources task. There are 100 points available for this task, split up into 3 different sections. The first one is to navigate to each of the different sites and analyse them for their content of either ilmenite for the ilmenite samples or their water content for the icy water samples. There are then additional points available for gathering that icy sample and then processing it and turning it into liquid water. And then thirdly, there are points available for a presentation that the base station team and other team will be conducting to judges shortly after the conclusion of the task.
It's running
Hi, Eric Grinders. Oh, Eric. Nice to meet you.
It's me. Thanks for sponsoring supporting. I did form SE, which is great. Where are you based?
I'm in U.S. Peoria. But part of my role is in engagement with external.
Yeah.
I'm in the foundations.
Yep.
So with universities.
So you can see, whilst the Monash Nova Rover team's task time has started, the team is just taking a couple of extra minutes to make sure that the rover is working as you intend. So you can see some team members there getting on their stomachs and looking under at their special payload that they've got just for this task to try and acquire and then process that icy sample to get some liquid water. Just making sure that everything in there is working as intended. And then once they're ready to go, they'll step off the field and then the base station team will take over and start operating the rover remotely with no line of sight of the rover itself.
This one's Kevin's university. Yeah, I'll send it. Why did he join the team? Well, he could have come to Apple.
I know what it's like. It's very, I'm sure you're very used to it.
Yep. We have also product development.
So it looks like the field team is clear. The rover has started to move, so they have started this portion of the task. So they lost only a few minutes there in the end, and they'll have 37 minutes to complete. And they're not wasting any time whatsoever, and they're heading straight into our crater to have a look at those icy regolith samples. So you can see that's a great shot of the front of the rover there. So they've got that special payload. Like I mentioned before, they've opted to go for an ice pack to help cool that condenser and maximize the amount of liquid water that they're able to produce after heating that sample.
There's a lot of comparison. Right. A lot of sitting around, not much, not always a lot of.
So you can see we have 2 samples designated by those black triangular little markers there. And so they will be denoting the 2 samples of icy regolith that we have. Like I've mentioned before, we have both a high water content and a low water content sample. And so these are pretty typical of the ranges of water that you might expect to find on the lunar surface, particularly around the polar regions in what we call PSRs, or permanently shadowed regions. These are extremely cold because the sunlight never actually gets to them. The reason for this is because the moon doesn't have an axis tilt like the Earth. I'm not sure exactly. The axis tilt of the Earth is something like 17 degrees. Does anyone in the audience actually know? 17 degrees? Everyone's shrugging. Perfect. Let's go with 17 degrees. Don't fact check me on that. Whereas the axis tilt of the moon, it does have a tilt. It's just very small. It's about 2 or 3 degrees. And so because of that, the very polar regions on the North Pole and the South Pole, if you're inside a crater, the sun never actually gets there. And so it's extremely cold because without an atmosphere, without any sun, there is no real way for heat to actually ever get there. So you can see on the rover, their payload is lowering some sort of probe or instrument into the first of that sample. So I think the black object with the white tip is most likely a hydroprobe, like one of the previous teams had today. And so that will be measuring the conductivity of that sample, and then so that hydroprobe will be measuring the conductivity of that sample and then hopefully being able to deduce what the water content is from that information. This is a view of the base station. So these are the camera feeds that the base station team are seeing and operating from. So they're all labelled there, which is quite nice. You got a couple on the mast fisheye, mast forward, mast down, and a bunch of others to help try and build that situational awareness picture of the rover and its surrounds. So like I've said many times, when you're out here looking at the rover, it's easy to be able to tell exactly where it should go to be able to navigate, line itself up. But when you're looking through just a handful of images, it can be really difficult to actually tell where you are, what you're close to, whether you're going to run into any objects and things like that. So the team would get points here for being able to just image those sites. There's 5 points available for each site. And then once they've determined the relative contents of water in each of those sites, they'll have the tricky decision to make about whether they should excavate regolith from the icier sample, which has more water content, but will be a lot harder, similar to ice, very, very hard and difficult to deal with, or whether they go for the low water content site, which might be easier to deal with, but have less water overall. So a reminder, there's 50 points up for grabs for processing and getting water in this task. 30 of those points are for getting any water at all, and then 20 of those points are for the volume of water that you get. So you are at advantage if you are able to generate additional water compared to the other teams.
How's the team doing? Very I'm not involved in the...
No.
Okay. I think it is just part of the game.
Yeah.
Then you can do it. Good. Well, thanks for saying hello.
So one unique aspect about Monash Nova Rover's Rover is their pivot wheels that they've got. So as you might have been able to see, each of those wheels can independently actuate and rotate about the vertical axis, which means that they can essentially move in any direction they like or any arc without actually skidding those wheels. So the University of Adelaide Rover team also had pivot steering, and they opted for the 6-wheel option, where the 4 outside wheels did the pivot, which means it can essentially turn on the spot. You can imagine how useful that can be when manoeuvring around these tight areas and considering which way you might approach each of the little sites and things like that. It looks like they're lowering that probe once again, potentially into one of the samples. Maybe just get a confirmation of the reading that they received previously before they move along.
I think so. They were Scorpio. Because I think that they can, for this task, I think they're well prepared. But they're already first since yesterday.
So you can see on here, reading the writing, they've got NIR spectroscopy. Jesus, it's a bit of a mouthful. So I'm assuming NIR stands for near infrared, which is the wavelength that instrument is operating within. And you saw the operator there going to manually save the reading that they had and note that down, which might give them an idea of the water content. You can see in the bottom left, they've got that NIR, or near infrared water calibration curve, which is essentially going to tell them, based on that reading, which is a little bit of an arbitrary number, 11,900 or so, based on that number, what then is the actual water content in a percentage of the mass of that sample. So they've done the calibration of that instrument before they've started the task. They've got that dotted green line which shows the curve, and then they'll be determining based on the reading that they're getting on our samples what that content is.
I think everyone's going at the 10th for debriefing, but I'm using this as research. Because everyone's like, no, you don't like everything. I'm like, go. So did ours work? I think it worked, but the drill got stuck, so I don't know. So I think people are processing the data. Because I think everything was on board. Because the other team, they had the unit that they were trying to use for analysis.
Hey. Wow. So you watch that?
Oh, there isn't? So you don't? What about you put it down?
Oh, really? Yeah.
No. You're all like, I was worried my hands were going to get close. I should have brought the filming stick and you can just hold it. I feel like I'm not hanging out with my group to watch, but I wanted to watch them in action. That's the real. Yeah, Kevin's one. Is he in his last one? They can get sponsored. No, it's the sun. Oh, the sun. We don't want to get the skin.
Somewhere around there. I don't think that it's
Is that the outdoor?
Yeah, because I think our engineering things and propose like a stage 2.
How long is it? Probably maybe. I was just like from my cousin's university. They're like, why did you join? He's like, yeah. He's like, he's going to be a fighter. Did everything go okay?
The drill drilled.
Yeah, that's a Did it get stuck or?
No.
Okay, that's good.
We don't think it got stuck. We just ran out of time.
Did comms drop out at the beginning?
That's what we couldn't really work it out. We're like, maybe it's comm issues because we've been having comm issues. Work great Monday, no, work great Wednesday, and then also just started going downhill from there, comms wise. But we couldn't tell on field if it was not that I was really on field. I was just running around carrying the toolbox. Like, we want the wire cutters, we want the multimeter, we want the zip tie.
I was worried the drill was going to jam to the line.
No, so here's the thing. They actually, apparently it looked like the wires were nowhere near the drill. Like it's on the basic.
Like we're still discussing. Did they get the whole piece out with this? I think they got a sample. Oh no, I think that's the near infrared thing. So I think it's like is it a covering till it starts? But then they can do some kind of reading. Our team was just like the people doing the research for that.
So it looks like the Monash team has been able to lower their iSpace Space Resources task payload to the surface of one of those icy regolith samples. So I imagine the intention there is that they're going to heat that sample up, melt the water, evaporate it, and then try and condense it. And so, like I said previously, they've opted for the ice pack, which you can see strapped to the top of that metallic house-looking shape on the front of the rover. I'm pleased to report that I was in fact wrong with the tilt of the Earth. It's not 17 degrees, it's actually 23 degrees. So thank you very much to a member of the audience for correcting me on that one. I should definitely know better.
I think from what I heard,
So you can see the tilt wheels again, the pivot steering, on the rover there, making good use and light work of the terrain out on the field there.
10%. But better than, I guess it makes sense though, you know, the drills were power capable.
So like when I was speaking to Pat from UNSW Canberra before, that's one of the key decisions that the teams have to make when they go ahead and design their systems. So obviously the pivot steering is fantastic to have, but it adds a whole bunch of complexity. You have double the amount of motors, double the amount of wiring, double, triple the amount of software required to actually control that. And potentially for newer teams, it's not the wisest decision, even though you do get a benefit from having those pivot wheels. So the crowd's giving a round of applause because it looks like I heard some whirring from the rover before. It seems like that processing system is in full swing. And you can see that, the Monash team is opting for joysticks as well as the Xbox controller to operate their rover in the field there. So I can still hear that whirring from the rover itself. So it's likely working away. And actually that their Space Resources payload is drilling into the sample, or it was retracting, to get the icy regolith from that sample back into the rest of the system.
Apparently, yes.
So you can see the rover is moving back and forth reasonably suddenly in a bit of a jerky motion. I imagine that is intentional, and it's probably used to get the maybe the acquired regolith to settle and to settle in the evaporator in the system there. Once again, it looks like they're retracting the drill that they had drilled into the sample with. So they're retracting that and then getting the material off the drill and into their system to process it for water.
I'm stopping. And I think this, this is the first yeah.
We have to do from day one.
That actually is so good predicting value. I know what that camera's going to do.
Clearly she was like, damn, well, Chris doesn't know how to get mixed up a lot of times.
Yeah. That's for everyone.
So why came here, I couldn't find anyone. And the judge it's a great fight.
It's going very well.
So the rover is still whirring away, still doing its thing. So a reminder, there are 20 points available for the volume of water that they are able to process and present to the judges in a liquid form, and additional points for the purity of that water. So we'll filter out all of the particulates and then weigh just the liquid water that's left at the end. And you get 30 points out of a possible 100 for this task for producing any liquid water, and an additional 20 for the volume or the quantity that you produce. There are then 30 points available for the presentation that the teams will conduct with the judges after the conclusion of the task. And then the last 20 points are available for navigating to each of the sites and imaging those visually, showing the base station judge on the screen, we've found the site, there it is.
Yeah, test it. Go.
So that evaporative and then condensing system is likely to take some time to be able to produce all of the water liquid water. So it's likely working away. In the meantime, it looks like the rover's going to head over to the ilmenite samples and see if it can determine how much ilmenite is present in the two samples that we've got over here.
When I decided to come back. My colleague and I went if it was a little bit different.
Like they're only like 40
So for some additional information on ilmenite, I've just had a bit of a look up. It isn't my background, so I apologize if any of this is incorrect. I'm sure the teams will yell at me if there's anyone in the stands who has a greater geological background. So yeah, based on the Apollo missions, they determined that there is potentially up to 5% ilmenite present in different lunar samples, and as well as using the metal components of it for manufacturing and things like that, you can actually reduce ilmenite into its components to produce water and oxygen itself. So it is a titanium-based ore, dark in color, very fine, that we've added to these samples, which Monash's rover is going to inspect right now. So you can see they're deftly moving the rover to try and line up their instruments with the sample, and then they'll go ahead and lower that, which you can see there, to try and take another measurement and determine what content of ilmenite is present within there. So like I said, there's ilmenite mixed with just general sand, which doesn't serve much of a purpose. So determining what the ilmenite content is the main aim of the game here.
Oh, there was too much data going to the checks. So then the communication had no one. Wait, do you want to go see the others, or do you want to wait until
So I think by my watch, the team will have just under 14 minutes left for this task. So they're making pretty good time, and I'm sure that processing unit is still churning away, producing liquid water. But whilst they're doing that, they're investigating our ilmenite samples to try and maximize the points that they can get. So there's 10 points available for traveling to and imaging both of those ilmenite samples, and then additional points available in the presentation to tell us what concentration of ilmenite is in those samples.
I don't think so. But like, they don't have a because I think they've got 4 wheels, so I think each wheel spinning for 1 motor, but then there's another motor to do the stay around. So it could just like drive forward back.
I mean, leading up to major milestones,
The others are just like going to clean up.
And like, I'm totally trying to put in extra time because sometimes you just don't get to have more people.
That's what those roads are still
Yeah. I don't know how to study uni and this at the same time.
I think I've got enough.
It's already there.
They might have been, but they hit
No, they just made that like they're super.
I hadn't noticed their back.
No, they need that much power sometimes.
I'm pretty excited to do it.
So you can see the Monash team using that pivot steering to its full effect, rotating the wheels constantly so it's able to laterally move in either direction, left to right, forwards and backwards, which is really useful for lining up their instruments over that sample, which you can see in the bottom of the image there. So I assume once they're lined up, once they're ready, they'll go ahead and drop that there you go. Drop that instrument to try and determine the ilmenite sample there.
Condenser. Yeah, gets the good water.
I don't think you can put anyone off. It's either like people already have access or it would.
The researchers, they can't share that.
Oh, because I got the microphone.
And I think like the main thing about this is the messaging. So like I think they've done a really good job to say
The temperature condition
to not say so that engineering
would so that we can get a good
I don't know.
they want to present it in a different way to show people to find it.
Oh, you got that?
But I think that's been the main thing.
Well, if they
Because the others are
close stuff this way, they can be
and like you get a good
Yeah. It's a fine line, but they've done it.
I don't want
So once again, we've got live pictures of the operators in Monash Nova Rover's base station. They've also got the Monash Nova Rover bear in front of them for moral support, maybe, or maybe just to hear them out if they're having any issues. So the team is pointing at the screens there, trying to determine what to do next, seeing if they can get those measurements going. So they have got just under 8 minutes left in this task. They're going to be trying to maximize as many points as they possibly can. In the meantime, I am joined by Iona from Monash Nova Rover, who is a member of the science team. Can you please introduce yourself and tell us basically what you do on the team?
Yep. Hi, I'm Iona. I'm on the science sub-team in Monash Nova Rover. I'm a second-year mechatronics engineering student. So I worked on the water extraction system, as we have all seen, with our drill that extends down into the water samples, extracting the icy regolith out, and then pouring it out into a kiln, which heats up the sand along with the ice, which then evaporates into the condenser and condenses on the cold surface. As you can see, we have ice packs on top of our condenser. Kind of looks like a little house. Those are just there to keep it cool and just to provide a cool surface for the water vapor to condense into. And yeah.
Cool, awesome. So, like I said before, it seems as though it was still whirring away as the rover was moving from the crater area with the icy samples over to the ilmenite samples. How long generally does that process take of collecting that sample and then evaporating all that water and then condensing it again back into a liquid?
So, yep, with that we did tons of testing and we found out that approximately 20 minutes of heating is about enough to get a reasonable amount of water. So with the competition strategy, we had our kiln on from the beginning so that it was still getting preheated while we were traversing to the sample as well. So the kiln was still being heated up, and then while we are doing ilmenite analysis, the kiln is still on, still getting heated up. And so just so that we can utilize all of the time that we can get in order to heat up the sand as much as we can.
Yeah, cool. So, like I referenced before, ilmenite lunar geology isn't my strength. We do have a guy for that, but he is busy. So, can you run me through how you are actually detecting the presence and quantity of ilmenite in those ilmenite-enriched samples?
Yep, so we have another sample analysis arm, as you all can see, which has a microscope as well as a near-infrared probe. So these are the two things that we are using for ilmenite detection. With the microscope, we get images of the sand mixed with the ilmenite, and along with the thresholding that we are doing, we can get an accurate measurement of how much ilmenite is present along with the sand. With the near-infrared probe, as you mentioned before as well, we had calibration curves of different concentrations of ilmenite mixed with sand. And yeah, so the near-infrared probe the system consists of an LED and a photosensor, which basically shines some light into the sample, and then the light reflected tells us more about the actual concentration of ilmenite present in there. So yeah, we just do some calculations in there with our software, and hopefully we get an accurate reading of how much ilmenite there is.
Yeah, awesome. Sounds like a complicated system, and I'm sure you can buy all these components individually, but integrating them all together, making sure they work, like you said before, testing it all as a system can be quite a challenge. What is the biggest challenge that you've faced in developing that system and in your work?
I think just integrating the software and the electricals and the science system itself was the biggest challenge, because we had to carry out extensive testing along with our software and electrical team, because developing the science is one part, and then we have people who are doing science in our team, but we do need to integrate that with the softwares and electricals, and those are two different sets of expertise, which is kind of sometimes hard to integrate, but I think with good communication in our team, we were hopefully, we were able to do a good job on that.
Yeah, awesome to hear. And also awesome to hear that you're getting that great real-world experience by having to work with those different streams of engineers that you might not always get in your university degree, but you'll definitely need once you get a job, once you graduate and all of that. I have one last question, and that is, can you get in the kiln?
Yes.
Fantastic. Thank you, Iona, for joining me. I really appreciate it, and best of luck to you and the team. It'd be interesting to see how you guys do in the task.
Thank you. Thank you so much for having me.
But like later on the presentation, like define, but we don't have to.
So you can see, as I was talking to Iona, the Monash's rover has continued working away back there. I think it's gone back to the icy regular samples to try and get more and more. Like I said, 20 points are available for getting the highest not the highest concentration, the highest volume of water from that sample. So they're going to be maximizing as much as they can with the small amount of time that is remaining.
whenever I'm on SPR, that I realize that Summit is like a piece of things in one. They have like so much more stuff to do than any other game. And so it's great that they can catch you on
But that's just to stay ready.
because they were killing last year.
I'm going to assume
Well, I mean, science always does well here, but it's just like a matter of this year they were like regular time. They were really good things in summer. They worked like super hard. I should have known the SPRs, but like on top of this, they've been planning everything. They've given so like a small especially we always like and we always work in the time like the night before the conference to get everything. But then this year they gave all the chemistry and software a month ago. Maybe like 2 weeks ago. They knew what they wanted. And they were just like,
So again, you can see the rover moving back and forth there, obviously trying to settle the acquired regolith, probably increasing the surface area that it has on the heating element to try and get as much of that liquid water out as it possibly can. They've got less than a minute left. That I'm sure their instruments are working as quick as they can to try and maximize the amount of liquid water that they're getting. Base station team working frantically on those joysticks there. So it looks like that has wrapped up the iSpace's Space Resources task for Monash Nova Rover. We'll tally the scores. They'll do their presentation shortly, and then we'll see how many points they've scored. So we have a short break now just for a little bit of lunch. I believe the next team will be getting underway at about 1 o'clock. For those of you joining us in person, feel free to head over towards the team sections. We do have the native Australian animals around, which should be a bit of fun. Otherwise, thank you very much for joining me. My name is Henry. I'll be joining you after lunch after a short break.
This is where it started. And where you start. This is where you find a top 100 university. World-class research. And these little guys. This is where you study crashes. And become cancer smashers. This is where you crush it. Cram it. Glam it. And this is where you grow food. For space. This is where your time begins. Make history at the University of Adelaide.
You're everything. You're like the overweight.
Well, I've thought he does mostly like do like eating stuff like that. But everyone else, like, over from that, you can make a plus map. Hey, I'll be going to the tent anyway, so I'm sure I'll see you.
How are we in space? Here you go. Oh no, you got it wrong.
Is my coffee coming out? I'm going to throw a coffee cup away. I feel bad.
Oh, man.
No one's here for
Oh, it's lunch break.
Yeah, which makes sense.
I felt bad because I just popped up here. I couldn't have any time to take a break.
setting up signs now?
Where is it brain? So you get it.
This is setup time.
Oh, yeah, we put one against the feet. So use the... Yeah.
Water. We will. We're going to leave one. Just go. I know, right? I want some.
Hello, everyone. Welcome back to the day 3 of the Australian Rover Challenge 2024. My name is Henry. I will be your host for this afternoon whilst the remaining teams compete in the iSpace Space Resources task. Up next, we have the RMIT Rover team, whose task time has just started, but they are just getting the rover ready to move on our challenge arena for their attempt at the iSpace Space Resources task. In this task, there are 3 components. The first one is that they need to navigate to our icy regolith, that's the lunar topsoil samples that we've added water to and then frozen. And they need to analyze them to try and determine what their water concentration is. They will additionally be required to then try and process that sample, take it on board their rover, or deliver it, in RMIT's case, to their processing plant, which they've separately placed on the arena. And they will gain points for producing liquid water. We also have 2 ilmenite samples placed out on the field. They will also be able to get points for telling us what the concentration of ilmenite is in those samples. Ilmenite is a titanium ore, a titanium-based ore, which is found on the lunar surface and is handy for a bunch of reasons, for reducing it to produce hydrogen and oxygen, as well as to produce metals which can be used for 3D printing on the moon or to build other infrastructure. So you can see RMIT Rover team's time has begun. They're just troubleshooting some last issues before their rover gets before the field is cleared, and then the rover gets underway.
Are you guys starting? You let us know when you're ready to go. And then you need to get off.
Then go.
Alright.
And I'll just confirm.
Oh, sweet.
I think they just handed it and then I just must have misheard it. Yeah, we're
Okay, field team is ready to go. He's coming along. Awesome. Cool. Yeah, I just looked like you were doing.
Sorry.
So all of the field team are clear of the rover and it has begun the tasks. They'll have 40 minutes. A little bit of that has already elapsed, so just under 35 minutes remaining for the task thus far. So again, their goals are to navigate to the crater, investigate those icy regolith samples, and also navigate to the ilmenite samples that we have here. And then the team will also be conducting a presentation in their base station for additional points with our judges.
The other director? Yeah, Amy's like, we're 50-50. Yeah. For business reasons.
So you can see the RMIT Rover team is also opting to use an off-rover processing unit. So this was a new option for teams to do this year. You can see that they've placed their processing unit just next to the water samples, obviously to minimize the distance that the rover has to travel with the sample before it delivers it into their processing unit. So the rover is making its way over into the crater where it will begin investigating the icy regolith samples within.
So this one's like regular samples. So you see the little black.
So you can see from the base station screen that we have on the screen here for you, exactly all the information that the base station operators have access to them. So they've got information about when each wheel is being driven, what the input is, what the excavator is doing, and several cameras as well. You can see it's a real challenge, a real world challenge on the moon is getting your cameras right to be able to perceive in such high contrasts between the darkness of space and the brightness of the sun, particularly in the polar regions where the sun comes in at such a low angle that it will definitely blind you in the direction that you may want to travel. So you can see that having adjustable exposure or some other way to adjust how much light is coming onto your sensors is really valuable to make sure that you can actually see where you're going. So based on the camera feeds that you can see here, that's all the information that the team operating this rover has available to them to be able to make decisions about where to go and what to do.
Who's the person that's operating? Over there. Oh, operating in there. I'm pretty sure. Oh. Or in there maybe.
Inside the tent.
There might be in that tent over there. They show them sometimes on the screen. Like our team was using an Xbox controller. But we had something go wrong. There was something go wrong at the start. And they spent maybe 15 minutes trying to fix the issue.
Where is this thing going to go up this hill? Up the crater?
There's a sample on the ground.
Oh.
I thought it was on the crater too, because the lady said it was in the crater.
Yeah.
This will explain the design of it and working on the problem solving and then pressure. It's all stuff that you have in the real world and even production.
He's going up the hill, I think.
Oh, he did his internship with Fleet, and they've just given him a day a week to do work as well for the rest of the year.
So they're happy with that.
Yeah, I don't know whether he heard me or I didn't hear him, but he was pretty finished his second year.
Hello.
He's in his fourth year of uni, but this is his first year on the Rover team.
I came here to support the chair.
So
I came here to scare you.
I thought myself that
You're too kind. You are too kind.
Although this is literally the worst
the
thing
same.
you can do right now. It's behind the hill.
Yeah, it is. Yeah, and the thing is, you spend most of the time there, behind the hill.
Well, this is right on the hill.
Well, yeah, there is. Then it's also kind of blocked by the box. The vision of this is kind of mostly on the screen. Or going around, but I don't know if we're allowed this time allowed to go around.
On the screen, spinning in the middle.
Probably
Just for sure.
I know.
But it's very interesting. Like,
I'm
this
skipping
road is
lunch.
quite
Skipping.
lean.
We have like a team lunch that we do every
Like
day.
the Adelaide one is quite big, and then there's another one that was, I was looking at it the other day, it was huge.
I'm here to watch you guys.
If you are,
So with the photo you
I
sent
don't think
us,
we can get rid of
made Aaron's look like this.
I can't.
When I
Oh my
first
goodness,
heard
but
about
that's
it, I
the
thought it
camera,
was smaller.
but it's bigger.
I just like the way he said 100 and something and then it's 4.
Yeah.
Nice. That's typical.
You
Like, they almost got me on the social because we're all so used to technology.
So you can see there's live images here of the base station team that are using, they've also opted for the joystick route to control the rover. And so they're assessing what they're seeing in front of them on their screens and trying to determine exactly what control inputs they need to do to line the rover up over those samples to take a measurement using their instruments. So they're at the icy regolith samples over in our crater there. So they'll be trying to determine what the content of water is in each of these samples, and then they can also opt to excavate from that sample, deliver it into their processing plant, which you can just see on the right hand side of the image, and then that will try and produce liquid water based off the material that's delivered to it from the rover. There's 50 points available for producing that liquid water, which is half of this task's entire points. The other 50 points are available for assessing the ilmenite material that we have placed on the field for them, and then the remaining 30 points are for the presentation which the team will be conducting after the conclusion of the task.
One of the leads in our group, I know him, he's a PhD, he's doing his PhD in geology, and he's been like a demonstrator for a couple of our classes and a few field trips. So hopefully he'll send a PhD over, so they probably did really well with that part. He's the only geoscientist on the team.
They work together with different skills and people overlap with their, you wouldn't want to find you. Is this better than some? See.
So where have they been practicing? It's like where have they taken little rovers? I think they have time where they can use this to practice. They will just do tests. I think they can just do tests in their designated space at uni and stuff as well. I don't think it's taking a sample, I think it's reading it.
So I'm joined by the man himself, Dan Ricardo here, who is the author of the iSpace Space Resources Challenge task. Oh my word. Don't worry about that. So we do in fact have a live one. Thank you very much. That is my lunch. We'll hide that behind there and we're away. So, Dan, we're essentially writing the rules for this task. What do you do? Why are you interested in this stuff?
Well, Henry, I guess it all started watching Star Trek with my dad when I was a kid, and then rush along a few years. Now, as we develop the rule set for the Australian Rover Challenge, one of the key things we're trying to address or trying to get these students to figure out and demonstrate out here on this magnificent field is how do you extract resources? How do you go find and prospect and identify the concentration of resources enrichments out on the lunar surface? And then how do you do an end-to-end extraction and processing? Now, one of the things we tried to optimize or allow the teams to do is processing either in situ on the rover, as some teams have demonstrated in the previous years, but we also try to open up the engineering space to get them to be able to process on an external module. And this is for two key reasons. One, as we continue to see some developments in the literature and also overseas space agencies, we see that individual rovers won't be doing dedicated processing and extraction. Instead, they'll have more fundamental tasks like a foundation services rover. But what we do see is rovers will be delivering material to external processing plants with dedicated hardware, power, and they serve two very separate purposes. So we're really allowing teams to decide what they want to do, how they want to approach this task, and trying to, as judges, give these teams as much opportunity and design space to really flex what they've learnt at university and what they're learning together. So beyond that, one of the key things that we're trying to get teams to think about is not only how they use their systems, but also science communication. And now this is part of the Space Resources presentation where myself and Eric from Caterpillar interview the teams and ask them how the data they've collected is valid and why they've chosen specific systems to be integrated into their rover.
Awesome. Thanks for the insight, Dan. So I agree. It's been really interesting to see that rule change in effect and see a number of teams utilize the separate processing unit. I can imagine it also simplifies things and it maybe makes it a bit more difficult because typically what we've seen is that you have to have a moving rover and have all those fundamental key aspects all working together before a science team or a space resources team can begin their work working on that payload. With the separate processing plant on the surface, they can sort of work in isolation and develop their own requirements, their own system, their own power, their own comms, their own everything, and that provides a lot of freedom. You still, of course, need to make sure that the interface between the rover and the processing plant is sound, because at the end of the day, if you're not able to deliver the regolith into the processing plant, it's bad luck. You're gonna have a bad day. So. Awesome, Dan. I think another question I have is, the ilmenite is new this year. Can you run me through a little bit of why you decided to go for ilmenite and what are the objectives that the teams are trying to do here, and what applications would that have on the lunar surface?
It's a really good question, Henry. So I guess why we decided to opt for ilmenite instead of another metal or mineral is because ilmenite is one of the key resources that was discovered in relatively enriched concentrations when we went to the moon in the Apollo exploration program. And one of the reasons why we chose it specifically for this competition is because, one, it's relatively easy and safe to purchase and acquire in Australia, at least. And two, it's relatively easy in terms of identification of, is it ilmenite, because it has such a high particle density. It's extremely black, so it has a very low albedo. And one of the reasons why we want ilmenite to be identified specifically is, as you were saying earlier, it's a mineral between iron and titanium, and we can use those two metals, if we extract and separate them, for a range of different in situ metal fabrication. So once we get to extract metal from the regolith, then we can use it for so many downstream applications, like Amelia Grieg was saying earlier, producing wire on the lunar surface, making sure you've got sheet metal for repairs, making sure you're not reliant on Earth sending you raw materials. Solar panels, exactly. So again, that's why we're really looking for ilmenite. But it's also quite relatively simple in terms of allowing teams to work with it, so in terms of the health and safety. And then also one thing we may be looking towards in the future is how to process it and extract it. And again, that's one thing that the teams can attempt at least, because ilmenite is slightly magnetic, which enables magnetic separation, particle size distribution, or separation because of that high density. So the world is their oyster. There's lots of things that they can do. For today, though, one of the big challenges is getting that icy regolith out of the containers onto their rovers, into those separate processing payloads, and then trying to get it all together to give us, the judges, that liquid gold, that water.
Yeah, and I've heard rumours that there have been teams able to process for some liquid water today, which is huge. Like I've been saying, 3 years in the challenge, this task has been in here, and not a single team has been able to produce any just yet. But today we have changed that, so that's awesome to hear. So thank you for the insight. Awesome to have you with such your expertise in the field designing this task for the students, and giving them a real red-hot challenge, but also fantastic to see them excelling too.
It's been a pleasure, Henry.
They normally do it at North Terrace, but they decided to do it here from now on. I'm kind of glad, because it was really annoying when they did it. They do it on the lawns across from the library, so they kind of have to cut off that whole area, lay all this stuff out, and then it's there for a week.
They don't want to travel too far to be able to find it.
But this looks like even arms, like it's a lot bigger than what they could do at North Terrace.
So when is Grandma's?
The 3rd of April.
So it's going to be out. My hairdresser, Antoinette, her grandfather, not quite 99, passed away on the Sunday, and their funeral is next Tuesday, so they don't know. Yeah. So I know it before Easter, but we wanted to do it over and done with. Yeah.
I think
in their yellow.
Yeah.
My business.
So the team has spent quite a long time over there at the icy regolith samples over in our crater. So I hope that they've been able to acquire some material there, and then they might be placing it in their processing plant soon to try and acquire that liquid water. So we'll see what they can do. Their arm is obviously still operational. They're still moving around, and that is another interesting novel approach that we haven't seen today yet. Like I've said before, it's fantastic to see all these teams approaching the problem in a different way. And so whilst other teams have opted to have separate units that they attach to the rover, this RMIT team is saying, hey, we've already got a robotic arm that works. Why don't we just attach a different end to that? And then we don't have to go through all the electrical, mechanical, software and integration issues that come with adding a whole new subsystem to the rover. So it's interesting to see that and interesting to see it pay off here. So it looks like they might be rotating a drill into place, which is on that new end effector, which would be specific to this task, and then maybe acquiring a sample shortly. So we'll see if we can see that drill spin up and get into and penetrate the regolith, which, like I said before, because of the iciness in there, the water content, the frozen water, it is just very, very, very hard. It is very, very, very hard and quite difficult to work with.
I know she's doing aerospace engineering, so it's not too far. She goes, oh no, my partner's over. Out comes the guy I was talking to, and it's her. No, small world, right?
Yeah. Like travelling back and forwards, that makes it a long day.
Yeah. One of them, he's there last night, 9:45, Aaron and I left. And he said, I've got an hour and a half until I can get home.
Yeah. It's too long.
He lives further on south. Oh God, but that's like me when I've got to go south.
You've got to get your sleeves in.
Well, you can see cars, a little bit of wobble.
Yeah.
But transmission's still alright, or it's a bit funny when it's cold?
It's not been great lately. Like this morning when I went to cross from Medlow Road across my north, like that intersection. Like there was no one coming, but I put my foot down and it goes. Like, I need to be on that road. That's an important intersection. If I'm not in that lane fast enough, I'm going to get hit.
So you can't take any chances. You have to make sure the road's clear before you go entering, just in case.
I'm used to it. Like, it happens not all the time. It does happen when the engine's warm on occasion. Sometimes my car just doesn't like it.
So you can see the RMIT rover team, their base station team is debating exactly what move to make next. So they're operating with those joysticks, deftly manipulating the rover arm or the rover itself there, trying to figure out exactly what next move to make based on the information available to them.
A difference. So I said to Dad, well, if I can put up with this for a year, I may as well just pay the $100 for the trans service and see if it makes a difference, rather than pay for a new trans.
So that's the next thing you need to do that.
Yeah, well, I need the wheel. The wheel was what I want done first, because that's annoying. The wobbling just made me feel uncomfortable. That's why I went for the wheel.
You got new tyres on?
No, the tyres still have legal tread on them. I need new brake pads for the back. They've got a little bit on them, but Uncle Johnny said I need them this year. There's a list, but you know, Uncle Johnny's working full time. There's only so many things I can get him to do at once.
Yeah, well, we want to see what's
we're
going on
actually
the bottom
going to
of
be
it.
overdue for that. Well, I've already bumped it up from 106 to 110.
Oh, I need a new battery too, because mine is
with air conditioning, closed blinds.
I had to buy a battery for the alarm system that kept beeping. We got a message from the people that monitor it saying it's your battery.
For $240 we'll send a technician out.
So it looks like their drill on the end effector there has come into contact with the sample. There's a chance they could be having some alignment issues. Not hard to tell from here though, and probably hard to tell from the base station. So we'll see if they're able to correct that and then acquire some of that sample to then process.
Well, that'd be a good idea. We'll all think about that.
Yeah, I've got sunscreen in the car.
Put some on before we go out.
Yeah, you're on the trouble side. Oh yeah. I was like, oh.
I'll just UI. Yeah, the UI is hilarious.
Is that the UI?
I don't.
What? There's like a rat or something.
Yeah.
Adding a timer internal. Adding a timer to the actual UI as well. So we're aware.
They've got good visuals, like cameras.
Spinning? Yes.
Like PlayStation. It's a live feed of that. They've got this, like the level of heads to do like powering.
They use the same code platform for the exact same. Yeah, socket
from the end border.
Socket on both ends, then displaying the signals. Good to know what the back. This is true.
Sonny Rover!
I don't know if you heard the end of pretty much everyone is using Wi-Fi here.
I mean, there's a very, very fine distinction between what we're using and Wi-Fi. It's the same frequency.
I'm not quite sure. Yeah. How well would Wi-Fi or radio or small antenna actually go through those sounds?
Not much. It gets very, disruptive. Especially on the higher bands.
Yeah.
It's going to get smaller antennas.
Adam said that's that next thing.
They never have to use it.
Fingers crossed. Actually, it made it sound like fingers crossed to be good. Separate system. Maybe a signature move.
So you can see the RMIT team have taken the field here. They're going to opt for the manual loading option. So like I described, I think Unimel took on this option before. So we want to give, when designing the rules of the competition, the fellow directors and I want to give the teams the greatest opportunity to succeed and earn any competition points they can. So if for whatever reason they're not able to acquire the regolith, the icy regolith from the sample, but their processing unit still works and it still can get that liquid water out, we're going to give them the opportunity to manually load the icy regolith, another sample that we've prepared, into their processing system, and then they'll still be able to earn points, albeit at a points penalty compared to if they were able to do it with the Rover itself.
Surely that's not a percentage, that's just the fudge.
You guys got a good view over here?
Wonderful. This is handy.
It's come over to the shade. You can actually
Probably want to bring the healing
Oh,
back.
so you go around.
Yeah.
Then you can actually see what's happening.
We went that way, but not that way.
There's a show.
So you can see the field team has cleared the field, and allowed the processing to take place. So the rovers are probably going to head off out of the crater, which, like I said before, could be one of those PSRs, the permanently shadowed regions, where you might find that icy regolith because it is so cold because the sun never ever gets there. The rover's likely heading over to investigate the ilmenite sample sites, which we've also put out on the field for them. Now here's hoping, remember that the processing plant is also a standalone unit, and it will require its own power system and its own communication system. So hoping that everything on there is nominal and that they're able to have begun that processing process.
Hey, you got material in there. 60%. Hey, if you get water, that's 30 points. That's still points.
That's it?
That's still like 12 points just for...
Yeah, we'll get points. We're happy with that. That's unfortunately didn't work as we wanted it to, but yeah, that's life. That's life. Just make it better next time.
Yeah,
That's
exactly. You're doing great.
How goes it? How you doing? I was going to find a bin.
So you can see the rover has made its way over to one of those ilmenite sample sites, and it's lowering that robotic arm to try and see if it can determine anything about the ilmenite content present within that sample. The team has just over 5 minutes left, so let's wish them the best for the remaining time to try and maximize the points that they can get. So the team has just over 3 minutes left to go, and they're trying their hardest to try and sample that site, maneuvering that end effector on their arm. You can see there's 3 prongs, I think, to the left-hand side, which is potentially some sort of probe. And so they have an end effector there which can rotate basically all the way around, which you can see it's probably doing right now. I imagine the intent is to try and rotate the end effector so that those 3 prongs are facing downwards, and then be able to skewer those into the sample to try and get some sort of scientific reading about what is present in that sample.
Is there an announcement, like a decision that's been made? She's actually off, but yeah. Yeah. So the thing is, the investigation is still going, is that correct? Or is it conclusion? That's really not good. That's an outright line. She specifically said that to start. Separate, absolute separate teams though, as an electric and combustion. 2 separate cars. But Harris wanted the city workshop, is that right? Or but why would I need to do that? That's all right. I'll give her a ring. Alright, let's see if I can get an update. No, I'm not. Look, I've got a backup. And I don't think completely. I can scrap them. So I'm okay with that. It's sort of at the. I don't think I can then. That's what I'm a little cranky about. That's why I wanted to try keep it going for that team.
So it looks like time is about to expire for the RMIT Rover team. Let's give them a round of applause for their efforts. Awesome work, team. Hopefully they're able to collect some of the data with that probe and also potentially process some of that manually loaded sample to collect some liquid water. They will be clearing their rover off the field now, and we'll have a short break, and we'll be back at 2 o'clock local time, just under 5 minutes, where the Swinburne rover team will be taking the field for the iSpace Space Resources task.
Where it started and where you start. This is where you become tomorrow's
cyber expert,
physiotherapist,
CEO, or musician.
This is where your time begins. Make history at the University of Adelaide.
Hi everyone, welcome back. Whilst the Swinburne Rover team is getting their rover onto the surface for the iSpace Space Resources task, I'm joined by Eric, who's representing Caterpillar, one of our sponsors for the challenge. So Eric, why don't you go ahead and introduce yourself?
Thanks, Henry. Eric Reiners from Caterpillar. I'm in the Automation and Autonomy organization at CAT as a program manager, and with that role comes responsibility for some of our external engagements, namely with universities and with government agencies. So in the U.S., that's like the Department of Defense and NASA.
Awesome. Definitely some big folks that you have to deal with, I imagine. Thank you so much for your support personally, and both from Caterpillar of the challenge. It's been awesome to have you guys on board and have all the team over in our team lounge. So just had a couple of questions for you. So what do you think Caterpillar's role in the next 5 to 10 years might be with the Artemis missions and humanity's return to the moon?
Sure. So we have been engaged with the aerospace community for many years. Dates back to the Apollo program, really, but more recently into the early 2000s and then up to today. And so in that engagement with aerospace in the U.S. with NASA, we are focused on areas of collaboration opportunity where we see the benefit of that technology development can impact our customers here. And NASA, in that case, NASA, the aerospace community, is going to be leveraging that to achieve their mission objectives. And so by working together, it's an opportunity to help accelerate the maturation of that technology for both our use and for the NASA mission extraterrestrial use.
Yeah, awesome. Those dual-use technologies have, those uses both obviously in space and then back on Earth as well. So you've been around the competition for the whole time now. We've also got the Mapping on Autonomous task tomorrow, which we haven't seen. But are there any challenges that you've seen the teams overcome or face, both whilst they've been competing or just operating their workshops, that Caterpillar also has to face either on a daily basis or otherwise?
Yeah, so at Caterpillar, as you can imagine, with us being the world's leader in mining and construction equipment, there's a whole range of technology that has to come to play to make those products capable and successful and so on. But we do have some very specific focus areas of technology right now in the areas of autonomy and automation, connectivity, and then electrification. And so when you look at this competition, these students are engaging in all of those aspects. So these platforms are all electric drive, electric actuation, battery powered. So the electrification side, they are all doing teleop control. So they have the whole aspect of the connectivity. And then of course there's the automation aspect and what we'll see more heavily tomorrow's competition part as well. So all these areas of prime focus or increased focus technology areas for us at Caterpillar, these students are engaged in the same technology areas in this competition.
Yeah, fantastic to hear. And it is, I'm curious to see tomorrow as well, Mapping on Autonomous. It is a really, really hard task. And while it might not look the most flashy, you need to have a really, really solid system before you can even begin to try and automate it and get it roving around the surface by itself, making its own decisions and all of that stuff. So I was wondering, do you have any advice for the students who are with us competing in the challenge, generally for their careers or generally if they'd maybe like to pursue a career with Caterpillar?
Yeah, absolutely. So the best advice I can give, and so I'm working with students quite often in part of my role, and so it's predicated on the 37 years that I've had at Caterpillar, opportunity for that. And so looking at what's really important to you in looking at a career, and for me, in that whole 37 years, and the key reason why I was at Caterpillar that whole time, are three key areas. One is growth, second is values, and the third is impact. So in terms of growth, at Caterpillar, I've had the opportunity to work in a wide range of roles and areas and had that ongoing personal development right throughout my career. So in product development, testing and simulation, production side and quality aspects, and then in legal agreements and contracts, et cetera, with government entities and so on. So just a wide range of areas and a lot of growth. Values. So every company will have a value statement, but I think it's important to understand what does that mean at that company. Certainly with Caterpillar, those value statements are not what we are aspiring to be, but it's really just codifying what is our DNA, right? And so that's really important in the environment that you're going to be working in, et cetera. And then finally, impact. So we all spend a lot of our day, or portion of our time, waking hours at work. And so it's important, I think, for most of us to know what is the meaning of that work? What kind of impact does it have in the world? And certainly at Caterpillar, if you look at what we produce, our products, the services, our technologies that in turn enable our customers, they are out really building the foundations of society. So if you look at construction, housing, where we do our shopping, road construction, how do we get around, et cetera, mining and resource access and all the critical minerals that are used across our ecosystem and environment, we're really foundational in enabling that to happen around the world. And so that's a key thing, knowing that you're having that kind of impact in the world.
Yeah, awesome to hear. It's quite remarkable at a large company that you're able to get such a diverse array of experiences. And so, like you said, 37 years experience at Caterpillar is quite amazing. But I'm sure it hasn't felt the same for all of those 37 years. That huge array that you listed just before. I was wondering if you could join one of these Rover teams today, which sub team or subsystem would you be most interested in working on, and why?
Well, first, I'd be happy to join any of them because they are all fantastic teams, right? And I'd probably feel a little bit hesitant, though, because they're such high-caliber students, right? But in terms of a subsystem area, I think it would be autonomy because that's an area I've been working in my career here over the last 15 years. And so I'm very, obviously, interested in that. And I think the competition affords the ability to really get into some of those key areas, perception, localizing without or in a GNSS denied environment, planning, how do you navigate around, but also, which is important for Caterpillar as well, excavation planning. How do you plan to dig up the surface, do your excavation, the whole material movement aspect of things as well. So yeah.
Yeah, it's honestly quite remarkable how so many of these tasks, and I mean, we've designed it in this way to not even emulate, but try and be almost identical to the same challenges that we will face putting these similar technologies on the moon, which is awesome. So one last question. It has been a little bit hard to pin you down today because you've been running around behind the scenes helping us out with the adjudication of this task. Can you run us through what have you been doing today and how have you found it?
Sure, I've been assisting in judging today, and so a big part of what I've been focused on is helping to get the next round of samples out in place that are going to be used by the next team that's going to operate, and then also participating in the presentation aspect at the end and understanding a little bit more detail about how they're going about the aspect of their prospecting and the excavation piece it's part of that sample extraction. And so those are the key things I've been involved with, and it's been just great to see that and to be able to interact with the students. It's been phenomenal.
Awesome, great to hear. So thank you again, Eric, for your support and Caterpillar's support of the Australian Rover Challenge. We honestly couldn't do it without you, and hope we'll have you on board for more years to come.
Great. Thank you so much. It's been great being here. Thanks.
So you can see we have the Swinburne Rover team out on the Challenge Arena at the moment. So their task time has started, but they're able to chew into this to make sure that their Rover is operating as they intend it to. So they're going to continue to debug and hopefully sort out whatever issues they may be facing. Like I said, these systems are just so complex that it could be a myriad of issues, one that they've never come across before, that's just managed to rear its head right at the wrong time. So we're crossing our fingers for them, and hopefully they can get underway very soon in the iSpace Space Resources task.
Video. Yep. You want to start jumper? Huh? Oh.
So once again, our fingers are crossed for the Swinburne Rover team who are out on the Challenge Arena at the moment, hoping to compete in the iSpace Space Resources task. They're debugging whatever issues they can as quickly as they can, and we hope they'll be on their way very shortly. Like I've said many times, and I'll say it again, there's just so much hardware and software that goes into these rovers that getting it to operate on the first go each day is very difficult. And so they've done a fantastic job to make it here. It is their first year competing in the challenge, and they have done exceptionally thus far. So let's see what they can do.
was like, hey, man, I'm figuring Rover. And I was like, yeah, just start the team. And I gave him Dan the number. And they started this team. Not even October, November. Like, how fucked is that? It's just never really got work. The real my way. Tried pivot steering? No. It looks like tank. So we're going now, join that like Christos Lewis. Oh, you want no, it's not. I was like, I can't hear.
Never mind, just on this church over there. Doğru. Bu her gün sabahsınız ama önce var mı sen aramak için öyle mi?
I don't think he does commentary. Yeah, happy to go to when
Maç böyle çok tamam. Bir zince. Nakurdan yapılır mı kolu? Nasıl değil mi? Ha? Bence sen bol bitti de. Bir konu ama danışma gelirsen bol bitmiş. İnce chat store ama.
I'm just not. I think he was in like an older now. Yeah. Yeah. You gotta get a fucking space. 5, 6.
No, I don't know if you will be with him.
Oh, okay. Interesting. That's just very frustrating. Yeah, the losses are going to be a loss in yeah, so I imagine 6 months. 6 months? Is it like into Rover and then second
So like, if you've ever seen Ice Space's mission profile, they use what's called ballistic paths. So they shoot out past the moon into sort of like, almost like solar space.
Yeah.
in my view.
We're doing a degree. Sorry.
Yeah.
No.
Yeah.
Sorry.
So one process that we haven't actually shown on the live stream yet during the competition, or maybe we have in the previous days, is the actual weigh-in and briefing process that teams have to go through before they compete in a task. So we have a small army of volunteers who are essentially helping us out to judge this task. And so they're all working behind the scenes at all times, when there's rovers on the field, when there's rovers off the field. And so right now, you can see that the UQ space team is undergoing their briefing. So this is well in advance of when they start their task, before they can start setting up their base station. Their rover gets weighed. It gets measured if it needs to be, to ensure that it's within the size and weight limitations that the competition imposes. And then they also just get walked through what the task entails and what they need to do for it. So they've got their rover on the scales there. They've also got their nice safe carry solution, which is a requirement of the competition to make sure that the teams can safely carry their rovers. Because remember, in some configurations, these things will be up to 60 kilograms. And so we want to make sure that no one is putting it back out, carrying these rovers around from their workshops over to the competition site or around the competition site. So The team over there will shortly finish up their brief. Then they'll probably have a couple of minutes to rest for a little bit before they head into their base station and start furiously setting up. They've only got 15 minutes to take that from an empty space, empty desks, to all of those monitors and those controllers, whether they're joysticks, Xbox, PlayStation controllers, keyboard control, whatever it may be, that they'll then operate the Rover with. It really is the shortest period of time, and that's why it is so hard to get the Rovers to work essentially just on command when you need it to in this high stress situation. So also a massive thank you goes out to everyone who's helped us volunteering today and over the weekend as a judge, as well as the rest of the team. So we have another small army of organisers who we have to thank to actually bring the competition to a ton of people who work in AV, project management, event management, a myriad of employees from the University of Adelaide, as well as Lachlan, Dan, myself, who write all the rules and interact with the teams and design the challenge. So we couldn't do it without any of them, and we appreciate everyone's hard work to bring you the 2024 Australian Rover Challenge. So you can see the Swinburne Rover team is still in their base station trying to debug the potential issues that they've been having. They'll be working furiously for the remaining section of their task time to try and determine what the issue is and resolve that and get their rover up and running to earn themselves some competition points. We have UQ Space, like we just showed you before, who've completed their briefing. So they'll be setting up their base station and then getting ready to compete in this task in approximately 20 or so minutes.
Good question. Good question.
So the Swinburne Rover team, they have the lid of the chassis open. We've got some of their engineers working on the issue, trying to resolve whatever's going on. It could be anything, electrical, communications, software, anything that could be holding them up here. And we've got our fingers crossed and hoping they'll be able to get underway shortly for the iSpace Space Resources task of this 2024 Australian Rover Challenge. So we might have some good news. It looks like the field team has cleared the field, and I can hear, and the Rover is away. So yeah, awesome work to the Swinburne Rover team for solving those issues, working through it, and getting their iSpace Space Resources task underway. Awesome work, guys. Let's see what they can do. So you can see in the base station there, it looks like the Swinburne Rover team is using a drone controller which has an integrated screen and joysticks or thumbsticks to be able to control the rover. So they've got a operator there having a look at the images that's being fed to them and then controlling the rover based on that. So they've navigated to the ilmenite samples over near our processing plant. So those are the two samples marked out with the little black rectangles. Unfortunately, it looks like the team does not have any sampling mechanism with them. So they'll have to be able to try and estimate what the concentration of ilmenite might be just from an image alone. So best of luck, it's still possible, but they're definitely up against it in that respect. So the rover is making its way. It's had a look at the ilmenite samples, and I think it might be making its way towards the crater where it will find the frozen, icy regolith samples, which it will also try and determine the content there.
Sorry,
Ok, dальше posto na نه اونجاش تمیزه اونجاش تمیزه
ولی کثیف میشه چیکار
Don't worry من دیگه نمیخوام
روم چیکار بهتر
You want to send a message to channel James? You want to send the channel? You want to send the link? Okay.
Oh yeah. Chicken chip chips.
Yeah?
Go for it. You want some?
Sorry about that.
Sorry, what did you do?
I didn't mention the lunch you made us. But
Wow.
they showed me yesterday.
And was
On
that
the
for
video.
the start?
No, he's silly. Don't worry about that. You don't have to.
This is chicken.
Well,
Imagine if it was hot. That's been an hour now.
Even gold are pretty good.
Henry interviewed me today or tomorrow. I'll mention it.
Oh, please, don't worry about that. My younger son is a bit cheeky. Don't worry. Naim, I think you have your shade. These are for boys. بخواد ببر بهشون بدی یکم اونجا بایستدن
We can send some
They're
up.
good, right? Best chips ever,
I
right?
think the oil is different. It's like a fat, animal fat in it as well.
Really?
Beef fat?
You know the oil? Yeah, it has to be.
This umbrella was a good idea.
Yeah, Naim told me.
Yeah, I'm jealous.
Yeah?
I've got another umbrella here.
Here, there is another one.
I'm just gonna get shade on
Go and get it. If you come and sit here, I can actually, it can cover, look.
Oh, thank you. We're doing some...
No, it's alright. You're holding, how about that? That cost you $100.
Yeah, like I know. Like, I'm getting payback from you.
How much time? That's the biggest size. We finished everything. No, it's okay. We did shopping yesterday. We've got stuff.
You like my selection?
Oh yeah.
So you can see the Swinburne Rover team in the base station currently assessing what to do. The rover has unfortunately stopped again in the middle of the field. So we're hoping that they might be able to get it up and running once again. There's only a couple minutes left, less than 4 minutes. So hopefully they can get it up and running. I'm not sure whether calling an intervention is worth it at this point in time, but we'll leave that up to the base station to find out.
I feel like Henry... Oh, no one's going.
No, they're gone. Did you ever imagine someone holding an umbrella for you?
No.
While you're competing?
No, last year it was just sun or rain.
Maybe in future they just do some shade.
Yeah,
like material.
Yeah, so when they had the people out here to design it,
yeah,
they came in winter.
Oh,
So the sun was in a different pattern. Because we get the sun standing over there. So we can't look out. So next year they're apparently moving it over there.
Does this wind affect your car, Rover?
Shouldn't.
It affects the sand when we try and dump it.
The sand, it will.
Okay.
Oh, you have to get more sand today?
No.
But yesterday some of the teams were pouring
Where
sand.
did it come from? From ocean?
Where did what come from?
The sand.
Oh, I don't know.
How many cubic they have brought? Lots?
Really good question.
Probably the desert as well.
This one doesn't look like the sand.
It's very fine silica sand.
Silica
It used to be warmed up.
It's alright. It will be warm
No, it's
in
so
your
good.
tummy.
1 hour. Very good.
Yeah.
Still crunchy.
Okay, so Lyle, I'm gonna info dump on you.
I'm not gonna remember any of it.
But I just need to say it.
Okay, do it.
So, ilmenite is actually
Okay, I'll clean it.
ilmenite in and of itself is quite common, but it's actually quite rare.
Okay.
But
Wait, it's common but it's rare?
No, I messed up.
Okay.
It's a bit rare, but there are sample sizes that are completely wild, from 0 to greater than 10% weight from Apollo's missions. A lot of it has been found in Med, Tor, anything for that again.
The name of the crater?
Yeah, down near south, about 837 Ks. But that is also a combination of ilmenite and other iron titanium oxides. Part of it being
So it looks like the Swinburne Rover team only has a minute or so left. They're working their hardest to try and resolve those issues and get over to the other sample sites that we've prepared for them. In the meantime, I'm joined by Bodhi from the University of Wollongong and their Rover team. So first thing is, Bodhi, can you please introduce yourself and tell us what you do on the team?
Well, obviously, sure, I can grab that. Obviously, my name's Bodhi. I've been part of the UOW Mechatronics Society team for about a year now, I think, and then obviously part of the Rover team for the past few months. I'm studying mechatronics engineering, so it's pretty applicable for what we do. Yeah.
Awesome. So it's great to have you guys here. It's your first year competing. Like we've seen with many other new teams, it is really, really, really hard, this problem. It might look simple on the live stream at home, but I assure you it's not just an RC car. There is so much engineering and development work that goes into this. Can you explain, based on your experience in your first year competing, what have been some of the biggest challenges that you guys have faced to get here?
Honestly, management, I think, has been the biggest issue. We didn't have a project manager for possibly the first half of our development cycle, and I think that has been a huge detriment to our ability to sort of get this running. I think, not competing, ever. The actual course itself, we underestimated quite a lot, especially the sand here. It's so much finer than we anticipated, and so we've, as you saw, we had to change our wheel design overnight to try and compensate for that.
Yeah, absolutely. And we recommend teams to practice on a beach or another sandy surface, because it is the closest that you're going to get. But like you said, even that isn't often not even good enough. And then what's even crazier to think is that actual lunar regolith would be even way finer than this. So we're as close as we can, but it's still incredibly, incredibly hard to mimic exactly the conditions that you'd expect on the moon. So so you said that you guys faced that adversity in the first day, but you were able to come up with a solution. Can you tell us a little bit more about that and maybe some of the other successes that you've had during the challenge?
I think just getting it running and moving was a major success for us. Moving forward specifically. We just sort of were roaming around Bunnings, and we're just looking at different things, how to improve the surface area or increase the surface area of the tyres, because we've sort of been walking around and talking to all the other teams. That's actually been a huge highlight, is being able to talk to all the other engineers around here, and just seeing all of their wheel designs, and this way bigger than ours, and our Rover's way heavier than all the other ones. So, sort of had to manage it some way.
Yeah, awesome. It's fantastic to hear about that problem solving, last minute, you have to come up with something. So roaming around Bunnings, finding a solution, that's awesome to hear. If there's anyone watching from Bunnings who wants to sponsor us, I'm sure there is a lot of components from Bunnings from all of the teams. So that's really cool to hear. So I was just wondering, what are you guys looking forward to? Hopefully we'll see you again next year. I'm sure you've had so many ideas. Like you said, talking to the other teams is fantastic. Collaboration is one of the pillars of the challenge. We try and foster that as much as we can. Have you guys had any, amazing, flashes of ideas or improvements that you want to make to the Rover before next year?
Well, one of the sort of big things is just having all of our wheels powered, or removing them and just having the 4 wheels. That's been one of the things we're talking about with the other teams. Is even some of the teams that have the 6 wheels, it just doesn't work as well as the 4 wheels. So I think we might have to pivot towards that. The other thing is just having software to run the Rover. Our software team is about 2 weeks old, and so the crunch time was insane. It was. I'm actually amazed that our software team managed to get what we had running. I think it was a bit of a shame. Our arm is, mechanically almost complete, but we just couldn't manage to get the software running for it in time. So I think for next year, just more time. That's the biggest thing.
Well, I can't lock anything in, but I assume that we will be back for the 5th Australian Rover Challenge, same time next year. Well, fingers crossed. So you got plenty of good ideas to continue and run with. I'm legitimately shocked that the software team is that young. Not young, by age, but had formed so recently. Shout out to you guys for getting that up and running. That is absolutely incredible. Honestly insane. Awesome work, guys. So thank you, Bodhi, for joining me. Awesome work having you guys here. Awesome that you have this really solid foundation now to then go ahead and be even more successful next year in what will hopefully be your 2nd Australian Rover Challenge.
Hopefully we won't drive off backwards next time.
Fingers crossed. Thanks, Bodhi. So we have UQ up on the challenge arena just now. Their task time is about to start. They still have people on the field. It's likely that they're just debugging some final issues. We might just cut to a short break before we get them underway in the ice space.
A lot more weight on my steps.
Honestly, we didn't know if you guys wanted to do it. And also, we did not realize. See, you guys like my entire subsystem, we only got 11 kilos. The fucking arm subsystem is only got 9. You guys think it's a bolting out of the way? You said it was going to be 15 kilos. Way more than
the rest of everything seems to play the I assume that I think Holland is going to be really good. Like at least you guys had. Like when you told me I was going to be 15, that was a point we were talking about. True. Yeah, if you really was going to reduce the rate, fix the cost, look for something or something. I think that's I think I prefer to go for like taking money. I think you guys no, I want to
What's that?
What's where to go?
Oh, speeding. No commentary? Okay. I guess.
No time on.
It was just easier than now.
We're going to the road arcs down there in case something goes up or what?
So it looks like, yeah, the UQ Space Rover team, oh, just UQ Space, sorry, and their rover are underway in the iSpace Space Resources task. Their rover is not wasted any time at all and is heading over to the ilmenite samples to try and investigate what concentration of ilmenite might be present in them.
So we've got 20 points total.
So the team has done a fantastic job setting up their rover, getting everything working. They're up and running. We joined them previously for their brief and saw them throughout that process. And they've been working non-stop ever since to get their base station set up and then get the rover moving. So they have what looks to be some sort of camera or probe on the front of their rover, which is actuated by 2 linear actuators. And I imagine that they will be lowering that to the surface to try and determine what might be in these samples.
So no matter what, you can either get water or you can get oxygen. You can get oxygen or you can get.
We didn't do a presentation on them afterwards.
Oh, yeah, sorry.
That's why we're looking at the papers.
So yeah, you can always get hydrogen, you can always get oxygen. You can always get oxygen. There's another one here.
No, that's okay.
No, I'll hold it.
Baka mabigyan na? Abala.
Pero no, ako dito ko na dala.
This is tiny.
And the handle is broken.
So I am curious to know a little bit more about this sensor that they've got on there. They drove up to the first sample and didn't actually lower that to the surface. They just placed it above. So I'm curious to know whether they are getting the data that they need from having that sensor. It's about 15-20 centimeters above the surface, analyzing the sample beneath it.
Thanks, Henry.
Best chips that they're gonna
You have questions? Ask me.
So there you go. There you can see a great shot of that sensor which is on front, and they've got a nice truss structure, obviously to save weight. And then there's the 2 linear actuators which actuate that up and down to the surface. It looks like the rover is wasting no time at all and heading off towards the crater where it will find the icy regolith samples, making light work of the traversal, which is great to see. You can see the base station images that the team in the base station and the operators will have to navigate off of. So they're reviewing these images and making decisions about where to go next and finding those samples.
Mapping. So that biggie on like Tradu Tachias to the GS. That's a rough day.
So the rover is positioning itself behind those two icy regular samples. So its objective here is to both analyze what the water content could be within those samples, and then also to try and excavate some of them to produce liquid water. So there's 50 points up for grabs to try and produce that liquid water from those samples. So you can see the base station team here looking like they've opted for keyboard control. So they've got the keyboard out, and they are using those keyboard keys to control the rover. You can see how important remaining calm and assessing the situation, working together as a team can be whilst you're working together in that base station environment. It can be quite stressful in there, with the clock ticking down and the time pressure to try and maximize the amount of points for your team. Whilst months and months and months, even years of work goes into developing these systems, unfortunately, the nature of the competition is that it all comes down to how the rover can perform in 40 minutes of task time.
Wait, what was that? I put the sniffing tool out.
Yes, you hold it.
Chew. No, no, but show me.
So the team still has ample time remaining, just 31 minutes left on the clock. So they've got plenty of time to continue to analyze these samples and gather as much data as they can, which will give them an insight, or potentially give them an insight into how much water there might be in those samples, or how much ilmenite there might be in the samples that they previously analyzed. So after the conclusion of the task, the team will run a presentation for our specialist judges where they'll be quizzed on exactly how they employed their scientific methods and how they were able to determine what the concentration of the different minerals and the water in those samples was. So you can see the team from the base station there saving those images as they're going so that they can show the judges in that presentation. So they'll be highlighting any visual indicators that might be able to give them any insight into those samples and what that insight could be. For example, with the water samples, perhaps the darker coloured one might be an indication of a higher percentage of water.
I'm like cooking here. So hot.
You know what else is going to get hot?
Icy regular.
Excavations.
Well.
Thank you. Oh. Oh.
I'm gonna go stand in the shade.
That sounds like a plan.
Do you want to join?
Huh?
Do you want to join?
Yes. I've done my reading.
So it looks like the instrument that the rover does have on it has been lowered towards the surface. Like I said, it's got that the truss structure with those circular cutouts, likely to save weight whilst maintaining as much rigidity or strength as possible. And then the 2 linear actuators. And it's interesting to see they're almost lifting up those front wheels by driving that sensor or whatever it may be into the ground. So to help me deduce exactly what's happening here, I'm joined by James from UQ Space. So James, can you please first of all introduce yourself and tell me a little bit about what you do on the team?
Yeah, for sure. So g'day. Thanks. I'm James. I'm the Managing Director of UQ Space, which is the student space engineering group at UQ in Brisbane, Australia. So we do the rockets and the rovers, which is very exciting. As a Managing Director, I'm kind of responsible for running the team, making sure everything goes smoothly, everything gets done, all the logistics are organised. We've got all the equipment and the tools we need to make things and make sure we get down here okay. So we're looking at trying to extract some water from the system over here. That module on the front that you're talking about is a heating unit. So it's a hollow cylinder effectively with insulating material on the outside. And on the inside, we've got 3D printer heating cartridges that are being plunged into the dirt to then heat up the sample and hopefully evaporate some water that we're then able to collect.
Yeah, cool. So, so you can see that on the screen there. So you got those, 3D printer heater cartridges heating up the sample there, trying to evaporate that water. What sort of temperatures are we dealing with? And then where is the water going after that point?
Yeah, for sure. So looking at about, potential up to about 200 degrees, 3D printers can get in excess of 300 degrees to melt the different plastics. But about 200 is kind of the peak we're looking at here to comfortably boil that water. And then it's just collected on the top of the module and then can coalesce down into a small vessel is the idea, that can then be quite easily extracted to give back to the judges.
Perfect. Hopefully collecting that liquid gold that we've spoken about, that liquid water, which will net the team, so many points. So it's awesome to have you guys here in your 3rd year, I believe. Yeah, awesome. You guys are in the scheme of things, quite, veterans of the Australian Rover competition. I'm interested to know what's been easier this year, if you're giving it to your 3rd year, and then what's been a surprising challenge or something that's popped up that's kept you on your toes.
So previously, we've had a fair few issues with getting bogged, primarily due to the lack of motor power. So this year we spent a lot more time doing a lot more integrated testing and doing a lot more sort of mechanical design. And we can see pretty comfortably it's navigating the terrain with no issues on any of the days. It gets a little bit bogged, but it's always got enough power to get it well out again, which is quite exciting. We've got a much smaller chassis this year, so it's a whole lot lighter as well, which is working pretty well. Some of the main complications we've had, obviously yesterday we had a communications issue we'd never seen before, but we're fortunately able to diagnose that in 20 minutes and still have 20 minutes left to do a whole bunch of excavation. Probably the network issues are keeping us on our toes more than anything.
Yeah, absolutely. And that's an amazing feat by the team to be able to diagnose and solve that issue just on the fly there. Like I said previously, because the systems are so complex, just making it try and operate on a dime for the task can be so difficult. And like you said, James, you can just find, an issue that's never cropped up before, and then half the team have to figure it out on the fly under this time-pressured environment is extremely difficult. So awesome work to you and the team for diagnosing that. I was really excited to see your paver placement yesterday. Unfortunately, you guys did not have time to do that. Can you run us through what that was and how you came up with that idea?
Yeah, for sure. So our pavers were taking the form of a dust mitigating road was the idea that rovers would be able to drive on. They were stored vertically inside a paver box that our excavator could pick up. So the idea was we'd drive over, pick it up, and then could lower one paver at a time, lower one, drive back, place another one, drive back, place another one, to basically potentially ad nauseum make a really long road, continuing to reload that paver box from a fictional lander if need be. But the idea was we had 12 pavers loaded in there to make a road that was going to be about 1.2 meters long.
Yeah, awesome. I'm sure, it would be fantastic to see some images or video from that happening during training, because, it was a shame that we weren't able to see that yesterday, unfortunately. So you guys are still sitting, I think it's maybe fourth currently on the leaderboard, which is awesome to see. Do you guys have anything up your sleeves for either this task or maybe tomorrow that might send you a little bit higher?
Nothing we want to reveal too publicly, but we're feeling pretty confident for the mapping task as well. And obviously after today, traversing the terrain so easily, no network issues this morning or this afternoon, we're feeling pretty confident we'll do well this afternoon as well.
Perfect. Yeah. Best of luck for the rest of this task. I hope you guys do really well. And then also for the mapping and autonomous task tomorrow, where, like you said, don't want to reveal too much, but anything can happen. So best of luck there, and best of luck for the rest of the competition.
Thank you very much.
Yeah.
We got the director of the Andy Thompson Define.
Jack's got a face. Cal's got a face. Which is right.
Thomas has got a, like, he kind of looks like worried. Rover's roving.
The breeze.
Now just having a, now it's just talking shit. We're just about the A-a-days.
So the teams, UQ Space, they still have 20 minutes left, which is a ton of time, and they've been sitting over one of those water samples for quite some time. Like I spoke with James about, heating it up, trying to evaporate the water which is locked inside that sample, and then condense it back into liquid water. So they still have tons of time to continue to pursue that dream of liquid water in the iSpace Space Resources task. So we wish them the best for the rest of it, and we'll continue to see how they go. Meanwhile, coming up last today in proceedings, we'll have QUT Robotics Club, or QUTRC. They'll be kicking off their attempt of the iSpace Space Resources task at 3:30 local time, which is just over 25 minutes away.
So it means you can make possibilities as well when you make decisions, isn't it, for body?
Yeah, sure.
And is that what Oppo, the other one doing? Not Oppo, the other one. Mega. She's doing something biomedical, and when they operate someone, I think part of the machine she's the one who puts the injection in that special muscle to relax it or whatever. She doesn't do operation, but
Like anesthesia, just something.
they are different, but hers also is different. It's big advantage.
Okay, I'm gonna give it a push up again.
Yeah.
Well,
Seems like a total shit.
So it looks like the UQ Space team is quite relaxed over in the base station. I don't see any, and I think they can hear me. I don't see any hands on keyboards. Oh, now they're busy doing stuff. So they're in deliberation about something. They might be waiting for that unit there to heat up, because it will take a while to heat up to that 200 degrees that James, who joined me previously, was talking about. So might be waiting for it to heat up, waiting for it to evaporate that water, and then trying to condense it back down into liquid form.
I love chatting.
What, the team left you?
Pardon?
The team left you?
Oh,
Are they all over there?
We got one person over there. We got one person with Henry over there. We got one with their family in the shade, and the rest of the base station. Just wait. Just again.
How's it done?
Huh?
Can you tell?
How's it done?
Yeah, how's it doing?
Oh, I believe it's going pretty well. We're just pumping them. Sorry, I'm about to say something not proper. Just pumping it.
You don't have to worry, it'll be fine.
We've had some great phrases in the team of just pump. One was I'll pump. I believe we're just pumping currents with Boston at the moment. Having fun, Henry?
Always.
Yeah. Can we have more shade?
Yeah.
Well, let's hope you guys got some water.
We believe we will. As you can see, it's nice and in there.
Oh yeah.
So we've got.
What's it doing when it's down like that?
So we've got four 3-string in cartridges in there that can get up to about 200. Each can get up to about 200 degrees, and then we've got
Three of them.
3 or 4. I can't remember how many we're
So
actually
you're
running.
putting a lot of heat in it.
Yeah, we're running with diamond patterns on the inside, so we get a bit more of we get a bigger surface area, so bigger, for more thermal transfer between them all. And we had 20 minutes. We finished the first. We did everything we had to beforehand, and now it is just wait.
So it drives it. You heat it up. Is it doing some sort of condensation then of it?
Yes,
It's
exactly.
Okay.
The premise is a solar sail. Not solar sail, a solar cell. So it'll all condense to the one point and go into a little container below it. The goal of that is that if we wanted to, you could do that a lot. You can do that more efficiently with a clearer container. But we are on Earth where we're in Australia. We get some good solar radiation, but not that much compared to the plus 200 degrees Celsius you go on the moon. So we need to heat it up more. But application to lunar, we just have a clear body.
It's great to see that actually, because usually you see a whole bunch of people getting
I'll say
excited about some sort of game release. No, that's the Rover announcement going.
I'll say, you're from Cat. You know anything about ilmenite?
No, I'm not on that side of things. I mean, about the geology aspect. We just dig it out.
Yeah, you just dig it up and know that you can't take.
The mines have geologists that decide what they're trying to do.
Oh, would you like me to move chair for you?
No, I'm fine. I'm gonna go back with the I see how you thought it was going.
Yeah, I think it's going pretty well. We improved from yesterday, so we don't have any of our communication issues. So, as you can see, people are relaxed, just having fun, having a chat. Except for
we need some team shout out.
You kill. Oh well, funny enough, not fun. I was talking with Ross Dungerville. Don't know if you had a chance to have a chat with him.
That's it.
Yes. His suggestion was to get one of those cheap little projectors so you can get. And during a bit darker, we could cast the university's image, like logo, on one of the hills.
Oh yeah.
The university would love that. They love themselves a lot.
Yeah. For sure.
Well, of course, localization. Yes, please.
Yeah,
please
good.
consume the water.
Let's see what you got. Well, hopefully we got some a lot of water.
Thank you very much.
We'll be back over anyway to talk to you about the presentation stuff.
Oh, you're coming to that?
Yeah.
Brilliant, thank you.
academics, so it's great. Support there. Exactly what I would think.
The politicians. No, I got new things.
What?
When you said that, it's looking pretty relaxed.
Yeah. Big bottom.
Who's me? We'll find out later.
Oh no, you can.
Awesome. So it looks like the UQ space team still have their instrument nestled in one of the icy regular samples in our crater there. So they're still trying to process that to get liquid water. Like James said before, heating that sample up, evaporating the water inside, and then recondensing it into liquid water. So they've got just over 10 minutes left in their iSpace Space Resources task time. After them, we have QUT Robotics Club. They'll be our last competitors for today, and they'll be getting underway in just over 15 minutes. In the meantime, I'm joined by Sam from the Australian Space Agency. So great to have you, Sam. Can you please introduce yourself and tell us a little bit about what you do?
Excellent. Yeah, g'day. Thanks for introducing me. Sam Webster, Australian Space Agency. I'm responsible for the Australian Trailblazer Rover program at the Space Agency. So it's great to see so many rovers out here running from the student programs today.
Yeah, awesome. Great to have you here, and thank you for your support of the competition. Can you tell me a little bit about the Trailblazer program and how the competition aligns, if at all, with what you guys are trying to achieve?
Yeah, so the Australian Trailblazer program aims to send a rover to the moon, Australian-built rover to the moon, around about 20 kilos, to go up and gather some regolith and drive around the moon. What you can see out here is a great test bed for exactly that. The Australian Space Agency is a sponsor of this program, and you can see a number of the activities out here align really well with what we want to do on the lunar surface. So all those navigation tasks, those going up and sensing tasks, what's in the ground, moving regolith around, or in this case, the sand that's out here is perfectly aligned with what we want to do, and it's great to see the student engagement, being able to do things with real applications that we're trying to achieve.
Yeah, exactly. It's fantastic also to see how we've been able to grow the challenge over the many years. I think the Space Agency has been a sponsor every year. We might have to fact check that. But it's been great to have you guys on board this whole time. And then, great to have Trailblazer, this national mission, so that all the students sort of have, the beacon, the light at the end of the tunnel. I'm sure plenty of them want to join. Do you have any advice for them if they might want to, continue this thing, and any advice for how their current work might feed into the future workforce?
Oh, look, the skill sets that you get from participating in something like this for rovers is just so important, not only for space, not only for the Trailblazer program, but for many of the Australian industries. There's a lot of industry from the resources aspect, and it's been mentioned a couple of times, but there's wide range of industries that have interest in that automation and STEM skills. One of the key pillars of the Australian Space Agency is STEM engagement and uplift of that workforce of the future. Trailblazer is only a small part of that. It helps with that Inspire piece, but it's great to see that engagement of the students here.
Yeah, awesome. And we're looking forward to working together to continue doing that and bringing more and more into the space workforce. Like we said, it's not just Trailblazer. Obviously, there's many, many activities that the Space Agency supports in Australia to continue to do that and meet those 2030 goals and targets that you have. Yeah, awesome. Has there been anything which has stood out for you over the weekend? Anything you've been surprised by or really excited by that you've seen?
Look, there's been heaps of things that have been great to watch. I think some of the most excitements come from the Bangladeshi team, so congratulations on those guys for getting down here and doing the participation. That's great to see. just the level of quality of the material that they're producing, like the Rovers are here really, really impressive for student teams. Getting to that level of capability, that's really a great achievement. And then we've had a few new starters this year as well, coming and dealing with those problems that are inevitable when you come and face this, and understanding how important that testing and qualification regime is. This getting this real experience and seeing that, and then how they've adapted to it. And then come back the next day and been able to participate and compete in the next events. They might have lost some wheels along the way, but they're back the next day. So it's a fantastic situation.
Yeah, absolutely. Some of the adversity that some of the teams have faced, but then they come up with a solution so quick. They're resource constrained, they're time constrained. They think of something, they come back the next day, they give it their best shot, and it's awesome. It's so awesome to see. So thank you, Sam, for joining me. Really appreciate your personal and also the Australian Space Agency's support, and thank you for being here to support all the teams.
Look, thanks for letting me be here. It's great to come and watch and see what the students are doing. This is very relevant material, and it's been very impressive. So keep on going.
Awesome. Thanks, Sam.
Digging, drilling.
Hey, is it Daniel? How is it? Is it super warm?
So it looks like the UQ Space team is still over where they were in that crater, trying to process as much liquid water as they possibly can. They've got just over a minute left of their task time. After that, they'll be able to gather and prepare all of the data that they've been able to collect. And then they'll be showing that to our judges over in their base station to try and get the final amount of points available for this task. So their time is just about to be up. And then after them, we've got our last competitors for today, and that's QUT, or the QUT Robotics Club. And they'll be having their go at the iSpace Space Resources task coming up in just over 5 minutes' time.
Where's the rest of your team? Gone. Oh, no. Have they got home?
No, I think they
Surely just around somewhere. Sure.
This is where it started. And where you start. This is where you become tomorrow's
Cyber expert.
Physiotherapist.
CEO. Or musician.
This is where your time begins. Make history at the University of Adelaide.
Yeah, because got in that car and goes. You go to e-commerce.
Yeah, but you've watched that first.
I don't think we have another extension.
So you can see next up on the Challenge Arena is QUT Robotics Club. So they have their rover Perseus just taking the field right now. They've attached their space resources payload to the front of it. It's quite different, so it'll be interesting to see if we can get a member of the team out here to talk us through exactly what's going on in that payload. It seems like it's a very large silver cylindrical object, which I'm sure might incorporate the similar evaporative condensing sort of methods that we've seen other teams get. And we wish them all the best with their attempts to get that liquid gold or that liquid water that every team is after in this iSpace Space Resources task. Their task time has started. They're just taking a couple of extra moments to make sure that their rover is up and running exactly like they expect to ensure that they are set up for success in the task. So I assume that once they're all ready to go, the field, the team will clear the field over there, and then the control will be handed over to their base station where they'll start driving the rover around and completing the task objectives.
Oh, you actually got chairs to sit on this time?
Yeah.
That's cool.
There's even like a little thing down there, so it's not as hard. My mum's saying hello to you, Abby.
What drink? Your cold drink. I'll go get it.
Pikachu.
You want Nanny to get it.
What? You have to apparently walk out to the car and go grab a drink.
It's cold.
Where is it?
It's in the back of the pocket at the back of passenger seat.
Well, that means I need the key.
Albie, you be careful, please. Yes, there. Yes.
I don't know where's
I don't know what's happening.
Where are the keys? Where are the keys?
Oh, my back pocket.
Ancora si c'è là. Ancora suono aperto. Sono passati là.
Lisa, you be careful, your shoelace is not tied up.
They got to get it to do certain stuff.
I want to go up there. Yeah.
Okay, but don't climb over the seat. Walk up the thing. It's too dangerous.
Well, they haven't come on the set.
Wiem, ale nawet co ty powiedziałeś, że będę chujowo.
No nie ma tam jeszcze kurwa zdjęć na mam wyglądać.
Ale chodzi o tak.
Ja pierdolę, przestańcie.
Dobra, i tak się powiedziałem.
Ale mamy na
Can you see the big screen and what's happening up there as well, Mum?
I can't see exactly what's happening, but can you hear what's happening?
Dobra, to jest prezentacja.
There's nothing happening at the moment. So you just take it on.
Okay.
At least they're on the field. They were running around like headless chickens last night. I bet they would have been this morning.
Czy nie dostaliście projektora sceny?
Nie, ale oni przysiedli po
They
prostu.
tested it out a bit last night, kind of put it off for me.
Gdzieś tak
wytłumaczył
dokładnie.
Tak.
Gdzieś tak szczerze, jak jest moment na decyzję, jeżeli to tak wysiadałem w przypadku Aktuela, bo gdyby było na zasadzie, no tu masz projektor i siedzimy w trzech przed tobą, a ty masz na projektorze, to jest stresujące, jak tak siadam, czyli
Swojsko bardzo.
Przez to jest tak, że łatwiej jest się trochę powiedzieć.
What about the one that was at the table with us for the wedding? Would he be interested in this too? Yeah.
Wow.
What did you think? Oh, have you had your pie yet? Hang on, Mum. You're just going to have to be like that for lunch. Oh, is it still in here? Or...
In the car. You can grab it up. I think it'll be a lollies
So it looks like the QUT-RC team are setting up in... Is that a picture of Daniel Ricciardo on their screen? Did anyone else see that? Is it? Thumbs up. It is Daniel Ricciardo is the screensaver of one of their base station... It is. Fantastic. I mean, I'm a little bit sad it's not me, but that's fine. Fantastic to see that you are being inspired by the challenge directors every day. So you can see their their screen here. They're just arranging their different camera feeds whilst the field team still is working to get the rover operational and up and running for this task. But going back to the base station team, I think commendations, and there's no bias here, but commendations to the QU2 team. I think they definitely have the cleanest base station setup. They've got the Pelican case with the integrated controls, which they essentially just whack down on the desk, open up the latches, and then they can just get going, which is really, really cool to see. Plug in a couple of computers. It is a really neat solution and really cool to see. They look very locked in, very focused. I'm sure they are going to be working through their operational checks. Hopefully they have some checklists, and they'll be up and running shortly in the iSpace Space Resources task.
Because that's what I think has an internal on it. We're really hoping it works.
Cool, they got some sponsors this year.
Yeah.
Is it their sponsors on their shirts?
I don't know. But I know that Caterpillar's been here. I know that iSpace has been here. ELO2
walking in soon.
here. I don't think Boeing was here. And the people that the company that actually works on the rover on the moon are here. And I know that which one's yours? His was that mostly yellow and white one. Well, right now the speaker should be able to hear what the dude's saying when he does things.
Sounds like he was in their teachers before, because he said, he was talking about their space.
Yeah. Yeah, that's because the speaker's right there. So you're not going to miss a thing that's being said. And then we've got some of the...
So it looks like the field team has just about cleared off. It looks like the QT team might be getting their rover underway soon and heading for either into the crater, which is in the back left of our challenge arena this year, which is where our icy regolith deposits are. I think I'm hearing the crowd cheer, so there's the potentially... Did it move? Oh, the mini rover has been deployed. So QUT have a bit of a novel solution to a problem, which is getting some good sight lines or good visibility of exactly what their tools and implements might do. So I don't know if we've got a shot of it, but we do have the QUT mini rover is up and running and is driving behind Perseus and offering an alternative point of view to the cameras which are on board the rover. So this is really, really, really cool to see. So you can see the close-up of the little rover there. So that basically is very bare bones. It's got a couple of motors on it. It could be 2, could be 4. I'm actually not sure. And then it's got 4 motors. All of those wheels are powered. It would have a little battery in it, a little communications receiver, and it's also got a camera as well. So it's setting up to the side to give a perfect view of the main instrument of the rover to make sure that the rover can line up with the ilmenite sample which it is positioning for right now.
That is so cute.
It is, isn't it?
What a great idea.
Yep.
I wonder if it's because I mentioned something.
This is mum of one of the boys.
She said it's cute and it's a great idea.
Yeah. Everyone just laughed at your comment just because they showed you. She was like so fucking quiet. So everyone heard you.
No, porque é que eu tinha esperado.
I wonder if there's anything to do with the idea because I mentioned it last year about or too about I wonder if you can use a remote control car by ears and maybe they thought we could do that maybe that's what they did.
So the little rover is behind that big sand pile.
Yeah, yeah.
And the big one is trying to extract the water from that one right in front of it.
Yeah, hopefully they can do it.
I've got Reese's phone, hopefully hitting both the big screen and the rover for you.
I can only see the rover.
Yeah, no, I'm saying I've got
Yeah, so it looks like you can see there that silver cylinder, which is likely their space resources processing facility. So they're at the ilmenite deposit right now. They've got that yellow instrument on the front, which they're likely going to try and penetrate into that ilmenite sample, and that'll give them some key data on exactly how much ilmenite might be in that sample. I assume they'll then be heading over to the crater to try and pick up some of that icy regolith and then process it for the liquid water. So just a reminder, there are 3 portions of this task. The first one is that ilmenite and the presentation, which the team will be conducting once they've wrapped up their field activities today, and that's worth a maximum of 30 points. There are 20 points available for just navigating to and imaging each of the sites, and I think that's what the mini rover might be doing right now. So whilst the main rover is out at the ilmenite sample trying to collect data, the mini rover has navigated by itself around to the crater to get some images of the icy regolith samples. The last 50 points are for producing the liquid water, which is what is so valuable on the moon and which is what we're hoping to produce once humanity returns to the moon this decade. And you can see the concentration on the operator's face there. The team are ingesting that data very quickly and trying to determine exactly what their best next course of action might be. And again, there's quite a number of them in there, all working as a team, likely with their different roles to figure out exactly how to approach the task and maximise the points that they're able to score.
Do you have your pipe? Are they both the same? Yeah.
Mum, I've never had a pine base before. Good job! Albie, can you quickly go grab that, please?
Can you catch it?
She didn't mean to. It just took off out of her hand. Yeah, literally got a face on them. Each one has got a different face.
Mine act like this.
Yeah.
You wanna?
So the big rover is heading between the 2 sand piles. And I think that going off to the one that's at the back of the sand pile that he was talking about before. Did you find him? Grab your mum's phone and call.
It's underneath there.
Oh, the little one's doing a pretty cool job. You won't be able to see it too much, Mum.
You could share your location with them, and you'll be able to see exactly where we are.
So we've got a great shot of both of the rovers working in unison here. So as one of the members of the centre said before, this is I think this is the first demonstration of teaming robots that we've had at the Andy Thomas Centre for Space Resource Xterra's analog facility. It's great to see both of these robots working together to fulfill the mission.
I've got it on flight. I had it on flight mode. Because I thought it would charge faster.
Give your phone to Reese so then he can show you his location.
Hey, Jackson.
There's a little robot between the sand piles.
Yeah, I got the speaker on.
Hello. So how far are you? Oh, okay.
You want to walk out to him?
Yeah.
Is that Andrew?
Yeah, he's just gotten here. He got lost a bit.
Oh dear.
Yeah.
We'll let you go here.
Yeah. He came straight from work to here, so he can follow us.
Yeah.
There's a big one. So the little one just looks like it's just stationary between the two sand piles. Oh, now it's moving somewhere. The big one, it's moving towards the sand pile by the looks.
It's going over it.
Won't be going over it today, no.
So you can see the QT rover there, Perseus, is aligning itself with those hydrated or icy regular samples, and it's been overlooked by Talaria, which is the name of the smaller rover that it's got there, named after the winged boots that Perseus wore. So great themes that the QT team has there to be able to give the names to both the bigger and the smaller rover in the same sort of theme. So it looks like the Perseus, the main rover, the larger of the two, is positioning itself over the first icy sample, and as usual, Talaria is watching over it by skirting around the back.
So having a tiny little one is saving time.
Yeah. It's helping them massively right now. I'm so glad that it's working because yesterday it didn't work for them. It came off Perseus but didn't move from there because the talking system was down yesterday. So I'm just trying to pull the hair out of my eyes. It's a bit windy.
Yeah, I'm upstairs watching the video. Kyle's robot.
Where's Daddy?
Going to go grab Grandpa.
So was it Kyle's idea for the little one?
No.
con palo.
Kyle's part is the big silver thing on the front. That's his baby on. It's been redesigned with a different purpose. Okay. Probably not right now, Albie. Wait until after
here's
this.
Grandpa.
Look, here's Grandpa.
He's gonna go stand in the shade.
Okay. You're gonna go stand in the shade with Grandpa?
Like
Bus robot's not right. Yes.
Here, Reese.
get footage from over there, please, for Mum. It's still recording. You got out of it. Alright, this is getting a different angle for you.
Okay, because I can't see what's going
Yeah,
on.
because they're going to go stand over there.
Yeah, it's
well, I
hidden
can't-
behind a big mound.
Yeah. You can't really see what's happening on the screen there because I can't zoom it in. Wish there was a zoom button. There's not really much to watch at the moment. I'll let you know when they start cheering.
Yeah.
When they start cheering, you know they've got what they need.
Change it to new dress out.
Not really. Hang on, let me put it back as big. Hang on.
Mi się wydaje, że nasze jest ciekawe, że LOL jedzie, LOL. Co? LOL jedzie. Tak, tak. No będzie, ale będzie...
What I can see on
So it looks like Perseus is still positioning itself over that sample. It hasn't moved in a little bit. They've got just over 14 minutes left on the task time. So we're hoping they're able to essentially position that instrument exactly where it needs to be over the sample. Like I said, I love this shot. It's got Talaria with that secondary camera offering that other view, which you just don't get that situational awareness when you're just looking through the lenses of the cameras which exist on the main rover only. So it's really, really cool to see that. Hopefully we'll see some sort of actuation soon from the front of the rover there, and something lowering towards that sample. So you can just make out the square or rectangular shape just at the front of it, underneath that yellow instrument, which looks to be, some sort of probe, some sort of instrument that might be able to tell the team or gather some data on how much water might be present in that sample.
Oh, of course you had to get that one.
Fantastic. Can you see the big screen, Mum?
There's not going to. Yeah, I'm looking at the screen, yep.
Because that's as close up as we're getting at the moment.
Yeah, I can see an image.
I'll just download or YouTube footage.
Yeah. Alright, Reese is gonna download the footage for you guys. And he'll send it to you.
Okay. Thank you. Oh, yeah.
Ja i lubię, ja ich tego typu teraz mam. Może się wydało. Great.
And what time has they got left?
So you can see the images. So this is what the base station team are seeing right here. So they've got quite a few cameras that they can look at, and so they're just trying to figure out exactly where they are, whether they're lined up, and what they can do to line themselves up and get a good shot at the sample which will be below them. So I'm sure the team is working really hard in that base station to see what they can do. But like I said, this just shows the value of having Talaria and that alternative camera view, because from the cameras just on board the rover, it is really hard to get any situational awareness whatsoever. And so having that third person view is so important, and would love to see that. You can see Talaria continuing to look over Perseus and giving that alternative view.
So here, and they say Brown or Britain don't work. Well, it bloody well does. You know who told you that, because it certainly does.
Yeah.
Even I didn't tell it, but it's the way it was. I just, since I've got to do it,
You guys, whatever you want to do, you could like just invite in, you know. They probably find a way to bring their robot. Oh, do you? Oh, then they could go and run that show and do a little demo. Oh,
I like how that dress actually comes down like on the ankle where your belly button. I'm sorry, what?
I've turned it down. 9 minutes and 25 seconds left on the clock.
They haven't managed to extract yet.
I don't know. It's really hard to tell what's going on. They've moved back and then now they're repositioning themselves back over it.
So you can see on the base station computer here, they've got a bird's eye view of those two sample containers with the Perseus just backing away from it. And then on the top right, you've also got the camera image from Talaria, the little rover, which is really, really, really cool. So it's also quite high definition, which is awesome. You can make out exactly what's going on, even the faces of our lovely judges over there. So Talaria is having a look, positioning itself to make sure that Perseus will be able to get into those samples and then hopefully determine what the water content is and also process those samples to try and get some liquid water. They've got under 10 minutes left in their task time, thus they've got under 10 minutes left in the task, so we are wishing them every success to try and get as many competition points as they possibly can in that time.
Well, I'm going to get the guys from it'll be like a direct engagement there. But I don't think you got a short tell. Well, there's some cameras there.
Back away. Look, we've lost speed. Back again. They've ran over the sample.
We've got
I'll mention it to him. I think that's a decent idea.
And Swinburne's not. That's like around the corner. It's not far.
To już do marketingu. Skarpety jest, czekam. White.
Nada.
Ja na gacie też czekam.
So again, we've got the two images, one from the smaller rover looking over the larger rover, and then another one of the rover itself. So this is what the base station team are looking at to try and control and try and maneuver the rover in place and in position to access those icy samples of regolith that we've prepared for them.
Yeah.
Sunscreen? Holidays.
Yeah. Yeah, in Poland it's like now it's probably 0 degrees Celsius, so
It's snowing.
Yeah, we are using as much as we can.
Fair. Cool. You guys ready for a finalist tomorrow?
Yeah, pretty.
Or a bit of work tonight?
pretty. We are pretty well prepared, but we will test it right afterwards.
Cool.
And you will work tonight?
Yeah, we'll do
It's
a little
only
bit.
geologist. Don't ask him.
Whoa.
So yeah, we're really worried about our suspension breaking again. So we're just not going to do much so that we don't fully destroy our suspension.
Okay.
So we're probably just going to do a small autonomous drive off and then kind of cut it there. That'll be it.
Okay.
We'd rather not break stuff.
Yeah. Yeah, we have the competition in United States this week, 2 months.
Yeah.
Guys!
So you can see our Polish friends enjoying the Australian sun. I hope you guys have sunscreen on. You do? Excellent. Staying hydrated, which is good to see. Eye protection on, hat protection on. Very, very nice. And we've got a flock of lunar birds who've just flown over the lunar landscape, casting a shadow on there. The team's only got 2.5 minutes left in the task. It looks like Perseus might be making its way back to the ilmenite site to see maybe if it can collect some more data there. Let's see how they use these last 2 minutes of the task.
Jest taka dziura ozonowa, że...
Wy będziecie tam w bazie? Też w bazie? Czy chcecie, nie wiem, na trybunach?
Raczej w bazie będziemy... Mamy
Yeah, it was literally as soon as you like tweet, I was just like, I was like intervention, I was like drill.
Zrobimy jeszcze raz.
Yeah, you should see it's clearly on. I'm just so surprised that way.
Będziemy klaskać?
Tak, i Igor nie spróbuje. Wyciągaj ten butel.
Albo tak zrobimy, tak...
Dobra.
I potem wchodzimy do kamery.
To brzmi jak tak.
Tak, byliśmy już na tym.
O dobra, jednak 10 ogarnąć. Dobra, 40... Guys, przygotujcie się, 50 sekund.
No wam nie pokażę.
Na co ty kamerę? Live'a.
No, na live tylko kamerę nie pokażę.
The universe's newest city is home to 1,000 people. And every year, over 10,000 come to visit. Only 20 years ago, this city didn't exist. It's the result of pioneers sending rovers, then discovering water. The hydrogen and oxygen separated from water becomes energy, creating the foundation for a fuel station. And with the fuel station came scheduled flights, followed by settlers. Soon, settlers required more diverse skills, attracting new specialists for construction, steel, communications, energy, transit, agriculture, medicine, and more. People travel from far and wide to see this new city. We call it Moon Valley. The moon is the new staging ground for your next level business. Expand our planet. Expand our future. iSpace.
Hey everyone, thank you for tuning in. My name has been Henry, and this has been the third day of the Australian Rover Challenge 2024. Today we brought you the iSpace Space Resources task. We saw 9 of our teams competing in that task, and some of them producing liquid water, which was a fantastic feat. Quite an achievement for these completely student-run teams to design, manufacture, test, and then deploy these rovers, which have then been able to produce liquid water from the samples that we've prepared for them on this challenge site. It's been really, really awesome to see. So unfortunately, for today, the scores will be published a little bit later, so please keep up to date on the Australian Rover Challenge website. We'll be publishing the scores later once we're able to wrap up all of the presentations that the teams will be conducting to tally those scores, make sure they're consistent, dot the I's, cross the T's, and then we'll bring those to you on the website and also tomorrow morning. Please join us tomorrow morning, starting from around 9 a.m, I think a little bit later potentially, 9:30 a.m. tomorrow morning Adelaide time for day 4 of the Australian Rover Challenge, where we will be bringing to you the Boeing Mapping and Autonomous task. That'll wrap up our competition, and so that'll be the day where the winner of the 2024 Australian Rover Challenge will be decided. Please join us then. Looking forward to it. Have a good evening.
Since opening our campus 150 years ago, we have constantly evolved. From our first pioneers in gender equality, we have inspired a new generation of leaders. If we saw closed doors, we'd be first to burst through them. As we have evolved the world around us, helping our students reach new heights. We have given shape to the laws of nature and the nature of our laws. We have helped preserve ancient languages while breaking new ground with the written word. Although we are proud of what we have achieved, we remain resolutely focused on the future. By continually becoming the change we wanted to see, the University of Adelaide has evolved into one of the world's leading universities. Because by making history today, we will build the world we want for tomorrow.